Hello there, and welcome to Science for Sleep, where curiosity gets cozy and the universe gently tucks us in with wonder. Tonight's quiet question might feel like one you already know the answer to. After all, you've seen the sun your whole life. It rises every morning, warms your face and paints the world in gold before it disappears beyond the horizon. It's the most familiar star we'll ever meet, and yet, almost everything we think we know about it hides how impossibly large it truly is. So tonight, as you settle into comfort, I'd like to invite you to drift with me through scale itself. How small are we really, compared to the sun? Not in numbers or statistics, but in feeling, in the way a single grain of sand might feel lying on the edge of an endless desert. Before we wander too far, I'd love to know, where are you listening from right now? Somewhere warm under daylight, or curled beneath the quiet weight of night? If you're finding this gentle exploration a soothing way to end the day, I'd be so grateful if you liked the video, or maybe subscribed. It helps this little corner of calm reach someone else who might need a quiet companion before sleep. But for now, just breathe easily. You don't have to remember any of what comes next. You just have to listen. Because somewhere between you and that star lies a distance so vast that even light, the fastest thing in the universe, needs time to cross it. And in that space, our scale begins to disappear. If you were to step outside right now and look up toward the sun, even through closed eyelids, the light would feel almost personal, a touch of warmth across your skin. It's easy to think of it as nearby, as though it sits just beyond the clouds. But the truth is more strange and more beautiful. The sun is about 150 million kilometers away. That's such an enormous number it starts to lose meaning, so let's think of it another way. If you could drive a car directly upward at highway speed, say 100 kilometers an hour, it would take you more than 170 years to reach the sun. You would have to pass the lives of several generations just to arrive at the place that fuels every sunrise. And when you finally reached it, you wouldn't find a surface to stand on. There are no solid lands or golden plains up there. The sun is a vast sphere of plasma, mostly hydrogen and helium, its energy constantly churning, folding and exploding from within. Its surface, if we can even call it that, is called the photosphere, a glowing ocean roughly 5,500 degrees Celsius hot. That light that warms your morning cup of tea began its journey there about 8 minutes and 20 seconds ago. Every sunrise is a message 8 minutes old, and that message travelled 93 million miles just to reach the side of your window. But before that light ever left the sun, it began much deeper inside. Deep beneath the bright surface, in the core where the temperature rises to over 15 million degrees, hydrogen atoms are fused together under unimaginable pressure. Each collision creates helium, releasing a small amount of energy as light. It sounds simple, but it's the reason we exist. Those reactions happen countless times every second, more than a trillion of them, and each one releases photons, tiny packets of light that will slowly make their way outward through layers of plasma. But here's something that might make your mind pause. Those photons, the ones that eventually reach Earth, don't travel straight out of the sun. They bounce over and over again. A single photon might spend thousands, even hundreds of thousands of years ricocheting from particle to particle before it finally escapes. By the time it leaves the sun's surface, the atom that emitted it may have ceased to exist. So, when you lift your face to the sunlight tomorrow, you're feeling warmth that began its journey perhaps 1 million years ago. A pulse of energy born before humanity ever built its first city. It's humbling, isn't it? To think that something so ordinary, so routine, is in fact ancient. A fossil of light that's been travelling since before your distant ancestors even looked at the sky with wonder. Now, imagine holding a model of the Earth in your hand. Let's say it's the size of a small marble, a little blue bead no bigger than your thumbnail. In that same scale, how big would the sun be? You might picture something the size of a basketball or maybe a car tyre, but it's far beyond that. If Earth were a marble, the sun would be larger than a 2-story house, 24 meters across. You could fit more than 1 million Earths inside the sun, not lined up neatly, but packed together like spheres in a vast glowing hive. Think of that the next time you see the sun's disk in the sky, and it looks no bigger than a coin. That tiny golden circle could swallow 1 million worlds and still have room to spare. Even Jupiter, the largest planet in our solar system, which itself could fit over 1,000 Earths inside, is only 1/10 the size of the sun. When we speak of being small, this is what it truly means. Not small as a poetic feeling, but small as a simple fact. The difference between a candle and a furnace, between a single note and the symphony that holds it, and yet somehow that enormous star doesn't crush us or burn us away. It sits at the perfect distance, close enough to sustain, far enough to spare. The Earth orbits at a distance known as the habitable zone, where liquid water can exist and life can flourish. Move a little closer and oceans would boil. Move a little farther and the world would freeze solid. We live in a slender, fragile range of safety, one degree of cosmic coincidence that allows everything familiar to exist. The grass, the oceans, your heartbeat, the rhythm of tides, all depend on that precise balance between our planet and the sun's energy. It's interesting to think about how much that distance defines us, not just biologically, but psychologically. The light of the sun regulates our days, our hormones, our moods. Without it, we lose all sense of rhythm. In winter, when sunlight weakens, people often feel more tired, more withdrawn. The sun is not only a cosmic furnace, but a quiet metronome that keeps the tempo of life. Plants open their leaves to it. Animals migrate by it. Humans, even surrounded by artificial light, still sleep and wake in its shadow. Every heartbeat you've ever had, every meal you've ever eaten, owes something to sunlight. Plants capture it in photosynthesis. Animals eat the plants. And we, in turn, eat the energy those plants stored. The food on your plate is, in the simplest sense, stored sunlight. A salad, a loaf of bread, even a piece of chocolate. Each is sunlight transformed, hidden inside matter, until your body releases it again as warmth and motion. You are quite literally made of sunlight. But if we step back further to see the sun as it really is, not a symbol, not a circle in the sky, but a star, something strange happens to perspective. The sun is enormous compared to us, yes, but compared to the galaxy, it's small. There are stars out there, hundreds, even thousands of times larger. Some would swallow our sun like a drop of water falling into a sea. This doesn't make our sun insignificant. It makes it precious. It's exactly large enough to sustain life without devouring its planets. It burns steadily, predictably, kindly, in cosmic terms. Many stars live violently, flaring and dying young. Ours is quiet. It breathes light for billions of years, and that quietness, that steadiness, gives us everything we know. The warmth in a cup of tea, the shimmer on the surface of a lake, the patterns on a leaf. All echoes of a controlled explosion happening 93 million miles away. When you think of it like that, being small isn't discouraging, it's miraculous. The size of the sun becomes a kind of comfort once you realize it doesn't care about size at all. It doesn't demand attention, it doesn't boast its power, it simply shines, the same way it has for 4.5 billion years. In that time, continents have drifted, species have arisen and vanished, and entire civilizations have appeared, built monuments to themselves and disappeared again, all beneath the same unblinking warmth. From its perspective, our history might look like a flicker, a single sparkle in a long stream of light. But that's the thing about being small. We see detail, we feel moments. The sun, for all its grandeur, doesn't feel or remember. It doesn't know that you looked up today and smiled at a patch of blue sky. It doesn't know that you closed your eyes and felt its warmth as something tender. The privilege of being small is that we get to notice. The sun burns without pause, but you can stop for a breath, for a thought, for a single glint of reflection. If you could somehow shrink down the entire solar system to the size of a living room, the sun would sit in the centre like a bright lamp, and the Earth would be a dust mote floating several meters away. You could blink, and it would vanish, and yet that little speck holds oceans, forests, laughter, music, and every memory ever made. Scale, in that sense, becomes a trick of perception. What looks tiny from one view becomes infinite from another. Our minds are not built to handle the true magnitude of space. Numbers fail long before we reach comprehension. We can say that the sun's diameter is about 109 times that of Earth. We can note that its mass is 330,000 times greater. But what does that feel like? Maybe the better way to think of it is through proportion we can sense. If the sun were the size of a hot air balloon, the Earth would be a single poppy seed orbiting 30 meters away. Or if the sun were a beach ball, Earth would be a grain of salt, a tiny glowing dot circling endlessly, fragile, persistent, alive. That difference in scale doesn't make us irrelevant. It gives context to how extraordinary it is that we can even ask these questions, that we can measure, imagine, and describe something so far beyond ourselves. The same mind that worries about daily life can also picture the core of a star. The same hand that turns a light switch can understand, at least roughly, how fusion lights the cosmos. Being small doesn't mean being powerless. It means being curious in a universe that doesn't require curiosity to exist. Every time sunlight touches your face, you are participating in something that connects you to every living thing that has ever existed here. Every ancestor who ever watched a dawn, every future being who will see the sun rise again. The same light, the same warmth, the same physics unfolding quietly across billions of years. That connection doesn't need grandeur. It's enough to make you feel held in the same pattern that sustains everything else. And so, as we drift deeper into this journey of scale, it's worth remembering that our smallness isn't a flaw, it's a feature. We're small enough to notice the warmth of a beam of light, to marvel at a horizon, to sense beauty in proportion. The sun is vast, ancient, and unknowably powerful. We're brief, fragile, and infinitely aware. And between those two truths lies something delicate and beautiful. The balance that makes awareness possible at all. If you've ever watched the sun rise slowly over a quiet horizon, you might have noticed how easily the world shifts from one state to another. Shadows soften, colours return, and the air itself seems to change texture. For most of human history, that moment was sacred not because of science, but because of awe. People built their earliest beliefs around it, told stories to explain its presence, and measured their lives by its rhythm long before anyone understood what a star even was. It's strange to think that the same sun you see today looks almost identical to the one your ancestors saw tens of thousands of years ago. The same disk, the same warmth, the same slow climb into the sky. Yet what it truly is, what we now understand it to be, is far more incredible than they could have imagined. When we say that the sun is a star, it sounds simple enough. But that single statement rewrites everything about how we perceive the universe. For much of human history, the sun was thought to be something unique, a glowing god, or an orb of fire travelling around the Earth. It wasn't until the 17th century that astronomers began to grasp the truth that the sun is one of billions, an ordinary star among countless others, only special to us because we live close enough to feel it. The discovery was humbling. We weren't at the centre of creation after all. We were orbiting a star in a vast sea of other stars, and that realisation slowly began to change how we think about our place in the cosmos. But to really feel that scale, it helps to imagine what the sun actually is beneath its golden glow. From Earth, it looks like a flat, perfect circle. But in reality, It's an enormous sphere of plasma, a form of matter so hot that atoms are torn apart into free-floating nuclei and electrons. It's not solid, not liquid, not gas. It's energy in motion, constantly boiling, shifting and reshaping itself. The surface that seems smooth and calm from our distance is actually a chaotic ocean, where convection cells the size of continents rise and fall every few minutes. Hot plasma wells up from deeper layers, cools and sinks again in a never-ending cycle that's been going on for billions of years. This surface, the photosphere, is what produces the sunlight we see. It's only about 500 kilometers thick, a thin skin compared to the sun's total diameter of nearly 1.4 million kilometers, but it's bright enough to outshine everything else in our sky combined. Above it lies the chromosphere, where temperatures climb again and the light turns a faint red during eclipses, and beyond that, the corona, an extended halo of superheated plasma that stretches millions of kilometers into space. The corona is so thin that it's invisible most of the time, but during a total solar eclipse, it emerges as a shimmering crown of light. That faint glow is hotter than the surface itself, reaching over 1,000,000 degrees Celsius, a mystery that scientists are still trying to fully understand. It's easy to think of the sun as a peaceful source of warmth, but if you could somehow stand near it, you would see something much more violent. Magnetic fields twist and snap across its surface, releasing bursts of energy that can dwarf entire nuclear arsenals. Solar flares hurl charged particles into space at millions of kilometers per hour, and massive eruptions called coronal mass ejections can send vast clouds of plasma outward, big enough to engulf planets. When those particles reach Earth, they interact with our planet's magnetic field, creating the auroras, the northern and southern lights that dance across polar skies. So even from 93 million miles away, the sun's storms can reach us, painting colour across our atmosphere and, on rare occasions, disrupting satellites and power grids. That energy, chaotic as it seems, follows a rhythm. The sun has an activity cycle that lasts about 11 years. During its quiet phase, its surface looks relatively calm, with few sunspots. As it moves toward peak activity, sunspots multiply, solar flares become more frequent, and the corona seethes with greater intensity. Sunspots themselves are cooler, darker regions caused by tangled magnetic fields that suppress the flow of energy. Each can be larger than Earth. Imagine a storm so big it could swallow the entire planet, and yet from our distance it's just a small dark patch barely visible through a telescope. All of this happens so far away that we can't feel it directly. But if you could somehow shrink the distance between Earth and the Sun, moving closer and closer, you'd start to see the light change character. From orbit, the Sun's brightness is almost unbearable, its white light cutting sharp shadows even in the vacuum. As you approached, the glare would become overwhelming long before the heat killed you. At a few million kilometers away, you'd be vaporized instantly, long before the corona gave you any chance to marvel at the view. It's not a forgiving star. But that's what makes its warmth from afar so perfect. It's distant enough to be gentle. We often forget that the sun itself is moving. To us it feels fixed, the anchor of the solar system, but in reality it's orbiting the centre of our galaxy at about 230 kilometers per second. That's over 500,000 miles per hour. Every planet, every comet, every dust grain caught in its gravity is being carried along with it. In the time it takes for you to take a single breath, the entire solar system has travelled thousands of kilometres through space, and yet, from our tiny vantage point, it all feels still. We wake up, look at the same sunrise, and never sense that we're moving through the galaxy at all. The sun's stability comes from an elegant balance. Inside, gravity is constantly trying to crush it, pulling its immense mass inward. But the energy produced by fusion in its core pushes outward, creating a perfect equilibrium that's lasted for billions of years. If the outward pressure weakened, gravity would win and the sun would collapse. If the fusion sped up, it would expand. but for now it sits in balance, a serene star quietly burning hydrogen into helium second after second. It's been doing this for about 4.5 billion years and will continue for roughly 5 billion more before changing into something new. Eventually, when it runs low on hydrogen, the Sun will begin to swell into a red giant. Its outer layers will expand, engulfing Mercury, then Venus, and possibly even Earth. The sky will turn crimson, the oceans will boil away, and the world will end in heat and silence. But that won't happen for an unimaginably long time. Humanity will have changed, evolved, or moved elsewhere long before then. After its red giant phase, the Sun will shed its outer layers, leaving behind a dense core called a white dwarf, a faint ember about the size of Earth, glowing with the last of its stored heat. Even that remnant will continue to shine for billions of years before finally fading into darkness. It's a strange thought, that the star we rely on so completely has its own lifespan, its own beginning and end. But that awareness also connects us to it. We come from stars. Every atom of carbon, oxygen, calcium and iron in your body was forged in the cores of earlier stars that lived and died long before the Sun existed. The Sun is not our origin, but our continuation, a chapter in an ongoing cosmic story of matter and energy being reshaped, recycled, reborn. You, sitting here listening to this, are literally made of ancient starlight. The hydrogen in your water, the iron in your blood, the calcium in your bones, all once drifted through space before finding home on this tiny world orbiting a middle-aged star. From a human perspective, the Sun feels eternal. It rises every morning unfailingly, even when clouds hide it. That constancy has shaped everything from calendars to cultures. Ancient civilizations built temples aligned with solstices and equinoxes, tracking the Sun's path to mark the passage of time. They called it Ra, Helios, Surya, Tonatiuh, each name a reflection of reverence. Farmers relied on its patterns to plant and harvest. Philosophers pondered its perfection. And for countless generations it was the most reliable thing in the world. Even now, in an age of electricity and artificial light, our bodies still align with it. The Sun is the clock we evolved under, and its rhythm still defines our sense of day and night, work and rest, wakefulness and sleep. There's a quiet irony in realizing that the star we depend on is utterly indifferent to us. It doesn't rise for our sake or warm us out of kindness. It shines because that's what stars do. And yet, that indifference has its own comfort. There's something reassuring about knowing that our lives unfold under a process that's steady, unbothered by human chaos. The Sun doesn't notice our noise, our conflicts or our ambitions. It just burns steadily, faithfully, marking the days with its light. It's not a guardian or a deity, it's a furnace. But that furnace is the reason anything can grow, live, or dream here at all. If you've ever seen images of the Sun taken through specialized telescopes, you'll notice something mesmerizing. The surface looks like a constantly shifting mosaic of granules, each one about 1,000 kilometers across, rising and falling in waves of convection. Dark sunspots drift slowly across that surface, some lasting weeks, others months. Filaments of glowing plasma stretch out and loop back, tracing magnetic field lines that look like invisible strings. These structures are vast, arcs of fire larger than Earth itself, moving with the grace of something both powerful and balanced. Watching it, even in pictures, gives a sense of scale that words can't quite contain. And yet, for all its grandeur, the Sun's light feels intimate. It lands softly on leaves, reflects off oceans, filters through curtains in the morning. The same light that scorches asteroids and lights comets is the same that warms a cat in a window or glints off a cup of tea. That's one of the quiet miracles of distance. It turns destruction into life. The energy that could annihilate a world becomes, with space and time, the gentlest force we know. The sun's influence extends far beyond light and heat. Its gravity holds the entire solar system together, keeping every planet, moon, and asteroid in orbit. Without it, Earth would drift aimlessly into the cold void. Its solar wind, a stream of charged particles flowing outward in all directions, shapes the boundaries of our cosmic neighbourhood, forming a vast bubble called the heliosphere. Inside that bubble, we are protected from much of the galaxy's harsher radiation. Outside it lies the interstellar medium, the thin soup of gas and dust that fills the spaces between stars. Our sun, glowing and ancient, carries its family of planets through that medium like a lantern moving through fog. If you could watch from far away, say, from another star, you would see the sun as just another pinpoint of light among billions. It wouldn't look special, it wouldn't stand out, but for us, it's everything. That contrast is humbling. The same object that defines our days is invisible in the broader sweep of the galaxy. Every living thing on Earth depends on it, yet from a few light years away, it would be just another star lost in the background. Perspective has a way of making significance feel relative, and maybe that's part of the quiet lesson the sun teaches us without ever saying a word. It reminds us that importance depends on distance. Up close, it's life itself. Far away, it's anonymous. The same can be said of almost anything. What feels immense in one context can be small in another, and that's not a contradiction. It's the nature of scale. We live in a universe where things can be simultaneously ordinary and extraordinary, depending on where you stand. So the next time you see the sunlight spill across your room, it's worth remembering that it's not just warmth, it's history. Each photon you see or feel was born in the heart of a star that's been burning for billions of years. It crossed 93 million miles of emptiness to find you, carrying the energy of fusion, the signature of hydrogen's transformation. It's light that could have gone anywhere, but for this moment it's here, painting your world with colour and life. Somewhere in that light is a quiet truth about proportion. The sun may be immense, but it's not unreachable. Its presence defines our existence, and yet it remains far enough away to allow us to exist at all. That delicate balance of distance, energy, and motion has shaped everything we know, from the patterns of climate to the beating of hearts. And as we drift deeper into the story of how we measure ourselves against it, that balance will keep reminding us that scale isn't about power, it's about connection. Because being small doesn't make us less, it makes us part of something that works perfectly. And somewhere within that bright sphere, in the ceaseless motion of plasma and light, lies the quiet heartbeat of everything we've ever known. If you were to try and imagine the true shape of the sun, your mind might instinctively picture a perfect sphere, smooth and golden, hovering quietly in space. It's an easy image, and in a way, not entirely wrong. But the reality is more complicated. The sun's roundness isn't static, and its surface isn't still. It's an enormous dynamic sphere of gas and plasma, constantly reshaping itself in ways our eyes can't perceive. The phrase ball of fire doesn't quite do it justice. Fire is chemical. The sun is nuclear. What looks like a simple disk from our vantage point is a vast layered structure whose scale defies human comprehension. To describe it as merely large is like describing an ocean as damp. When scientists talk about the sun's diameter, roughly 1.4 million kilometers, it's a number that quickly dissolves into abstraction. Our brains aren't equipped to handle size on that scale. You can say that more than 100 Earths could line up across its width, or that over 1 million Earths could fit inside it, and still the image doesn't quite land. Maybe the best way to feel its size is to imagine that you could somehow place the sun where Earth is now, and then step back far enough to see how it fills the sky. Its disk would stretch from horizon to horizon, completely overwhelming every familiar landmark. There would be no blue sky, no air, no world left to stand on. The Sun's surface alone would reach well beyond the orbit of Mercury and scorch the space where our planet used to be. That's the difference between imagining a star and standing near one. Yet for all that immensity, the Sun is still shaped by the same basic forces that shape everything else in the universe. Gravity pulls inward, trying to compress it, while pressure from fusion pushes outward. The balance between these two forces determines its shape. Left to gravity alone, it would collapse into a dense core. Left to the heat alone, it would expand indefinitely. But over billions of years, these forces have met in equilibrium, forming a nearly perfect sphere. Only nearly, because the Sun rotates. It spins once every 25 days at its equator and about every 35 days near its poles. This differential rotation causes it to bulge slightly at the middle, an equatorial swelling that makes it a little less than perfectly round. The difference is minute, barely detectable even with sensitive instruments, but it's there. A subtle flattening, the faintest reminder that even perfection bends to motion. This rotation isn't uniform because the Sun isn't solid. Different latitudes rotate at different speeds, dragging magnetic fields through layers of plasma. Over time, those magnetic lines twist and tangle, storing energy that eventually bursts out as flares or eruptions. It's an elegant chaos, a pattern of instability that keeps the surface alive with movement. You could think of it as weather on a scale far beyond Earth's. Sunspots like storms, flares like lightning, and shifting magnetic loops like jet streams made of fire. If you could somehow watch the Sun close up, you'd see the photosphere bubbling constantly. Each granule on its surface is a cell of convection, where hot plasma rises, cools, and sinks again. There are millions of these granules visible at any time, each about 1,000 kilometers wide. Together, they make the surface look like a shimmering sea of light, an endless pattern of boiling texture. It's mesmerizing in photographs, small structures constantly forming and dissolving, each lasting only a few minutes before fading back into the glowing continuum. It's difficult to connect that image with the smooth yellow circle we see in the daytime sky, but they're the same thing viewed from vastly different perspectives. Beneath that surface lies the convection zone, extending hundreds of thousands of kilometers inward. Below that, the radiative zone, where energy travels outward not by motion but by radiation. And deep beneath that, at the core, fusion continues relentlessly, converting millions of tons of hydrogen into helium every second. If you could somehow slice through the Sun to see its interior, it would look less like a fireball and more like a series of concentric layers of motion, pressure, and light. The closer you get to the core, the more extreme everything becomes. Temperature, density, and energy rising to levels that no physical intuition can grasp. But shape is not just about form, it's about function. The Sun's spherical symmetry ensures that gravity pulls equally in all directions, maintaining stability. If it were even slightly less uniform, the imbalance could cause wobbling, distortion, or irregular radiation that would ripple through the solar system. Every planet's orbit depends on that balance. The roundness of the Sun is, in a quiet way, the reason our world moves so predictably through space. We often think of the Sun as fixed and constant, but it actually vibrates. It rings like a bell, though the frequencies are so low that our ears could never detect them. These vibrations, caused by sound waves bouncing through its interior, are studied in a field called helioseismology. By measuring tiny fluctuations in brightness and motion on the surface, scientists can infer what's happening deep inside, much like how geologists study earthquakes to understand Earth's interior. It's a strange and beautiful concept. The Sun has a voice, and by listening carefully we can learn about its hidden layers. Helioseismology has revealed that the Sun's interior rotates at different speeds, that its core might turn faster than its outer layers, and that waves of pressure and gravity ripple constantly within it. These waves shape not only the Sun's structure but also the solar wind that streams outward from it, carrying charged particles through the solar system. That solar wind interacts with planetary magnetic fields, creating auroras, shaping atmospheres, and influencing climates. Even the faint tug of that flow helps define the boundaries of the heliosphere, the bubble of influence that separates our solar system from the wider galaxy. The sun's size also dictates how it holds itself together. The immense gravity compresses hydrogen atoms so tightly that fusion becomes inevitable. At smaller scales, that balance wouldn't hold. If the sun were much smaller, it would have cooled long ago, becoming a dim brown dwarf. If it were much larger, it would burn through its fuel in a fraction of its current lifespan and explode as a supernova. Our sun sits in a rare sweet spot, massive enough to shine brightly for billions of years, but not so massive that it burns itself out quickly. In the quiet balance between gravity and fusion, stability finds its home. Every part of the sun is in motion. Plasma flows from equator to poles and back again in slow, looping currents that can take decades to complete. Magnetic fields rise and twist, break and reconnect, powering eruptions. Particles stream outward, forming the solar wind that stretches far beyond Pluto. The sun is not a static sphere. It's a living system, dynamic and fluid, constantly reshaping itself. If you could fast-forward time and watch it over centuries, you would see patterns emerge like breathing, sunspots forming and fading, the corona brightening and dimming, the surface subtly shifting. And yet, even amid all that movement, its shape remains astonishingly stable. The reason lies in the sheer magnitude of its mass. The sun's gravity is so immense that it suppresses irregularities, smoothing out differences the way a deep ocean hides the ripples of a pebble. This is what gives it its roundness, a self-correcting symmetry born of gravity's grip. When a part of the sun bulges outward, gravity pulls it back in. When another compresses, heat pushes it outward again. The result is balance so enduring it's hard to imagine it ever failing. We live within the faint reach of that balance. Earth's orbit is not a perfect circle either. It's slightly elliptical, but the sun's overwhelming mass ensures that our motion remains consistent enough to sustain life. Each season, each tide, each steady year depends on the sun's stable shape. Even a small deviation in its structure could have cascading effects across the solar system. It's a reminder that what seems simple, a round, glowing disk, is actually the product of astonishing precision. Some astronomers have even measured the sun's oblateness, the tiny difference between its equatorial and polar diameters. It turns out to be less than 10 kilometers, a barely perceptible flattening in an object over 1 million kilometers wide. That means the sun is more perfectly round than most of the objects we can imagine. More so than Earth, more so than Jupiter, and more so than most stars. It's the universe's quiet way of demonstrating what equilibrium looks like when perfected by gravity and time. If you were floating just outside the sun, beyond its visible layers, you'd see the corona stretching outward, delicate and ghostly. That corona, for reasons still not entirely understood, is hotter than the layers below it. One theory suggests that magnetic reconnection, those moments when tangled magnetic fields snap and rejoin, heats the plasma to extreme temperatures. Another points to waves travelling through the magnetic field lines carrying energy upward. Whatever the mechanism, the result is striking. A faint, transparent halo hotter than the surface it surrounds. From a distance it looks ethereal, but up close it's violent. An ocean of charged particles whipping through vacuum. The sun's shape extends beyond its visible form through its influence. Its gravitational field defines the structure of the solar system. The planets, asteroids and comets all trace paths curved by its pull. That gravitational well stretches for light years before blending into the general field of the galaxy. In a sense, the sun's shape includes everything it holds. The invisible architecture of motion that keeps our world from drifting away. It's not just a sphere of plasma, it's a sculpture of orbits, the unseen hand that shapes the dance of worlds. When sunlight reaches Earth, it does so evenly enough that we rarely think about its origin. But the light you see each morning began as energy released from fusion reactions in the core, each one a collision of protons overcoming their mutual repulsion through quantum tunneling. That process releases gamma rays, which scatter through the dense plasma of the sun's interior, losing energy bit by bit until they emerge as visible light. By the time they escape, they've transformed from deadly radiation into the gentle brightness that nurtures life. The sun's shape, its density gradient, and its temperature layers all determine how that light emerges, how it spreads, and how steady it remains. The steadiness of that light is extraordinary. Despite all its turbulence, the sun's total energy output varies by less than 0.1% over its cycle. That consistency is why our climate is stable enough to sustain ecosystems. If the sun flickered like a candle, life here would never have had a chance to evolve. Its shape, both literal and energetic, defines the boundaries of habitability. To understand how small we are compared to it, think of it this way. If the sun were hollow and the Earth were inside, it would take over 109 Earths lined up side by side to reach from its centre to its surface. Each of those Earths would be dwarfed by the waves of plasma rolling above it, each wave rising higher than the Himalayas by factors of thousands. The sun doesn't just outsize us, it overwhelms every metric of comparison we can invent. And yet, for all that immensity, it doesn't feel foreign. It's woven into our lives so completely that it feels familiar. The warmth on your skin, the glow on a morning wall, the slow fade of daylight through a curtain, each is a direct experience of that star's surface. We exist within its reach, shaped by its size, its heat, its gravity, and its rhythm. You could say that the sun's shape defines the shape of everything else we know, from the orbit of our world to the length of our days. There's something deeply reassuring about that stability. It means that while we live our brief lives, worrying about small things and fleeting moments, the sun continues unchanged, vast, and steady. Its shape may shift slightly, its cycles may ebb and flow, but in human terms, it is the closest thing to permanence we can know. When you see it rise tomorrow, you'll be looking at the same form that has burned since the first humans looked up and wondered what it was, and long after we're gone, it will still rise, still shine, still hold its nearly perfect shape, reminding whatever future eyes might exist that stability and motion can coexist, and that even the largest things in the universe are shaped by balance. That balance, quiet and constant, is the sun's true form. It's not just a sphere of plasma or a source of light, it's an embodiment of equilibrium, gravity and energy locked in a partnership so precise that it's lasted almost 5 billion years. The sun's shape is the universe's long, patient proof that chaos and order aren't opposites. They're partners, dancing in perfect time. And every orbit, every dawn, every moment of light we experience is part of that same rhythm, unfolding endlessly, silently, above us. If you step outside on a bright day and close your eyes, the sunlight that filters through your eyelids feels instant, as though it comes from something close enough to touch. But that feeling, that illusion of immediacy, is only part of the story. Light from the sun takes time to reach you. It moves at the fastest speed known in the universe, yet it still needs more than 8 minutes to cross the gulf between the sun and Earth. Every time you see sunlight, you're seeing the past, light that began its journey more than 8 minutes ago, long before the moment you decided to look up. The warmth on your skin is history arriving on time. That delay might seem trivial. 8 minutes doesn't sound like much, but it's a window into scale. Light travels at nearly 300,000 kilometers per second. In the time it takes you to blink, a photon could circle Earth more than 7 times. And yet, even at that unimaginable speed, it needs 8 minutes and 20 seconds to reach us from the sun. When you multiply that by the seconds in those minutes, and then by the distance it covers each second, you get a number so large it becomes more poetry than arithmetic, about 150 million kilometers. That's the space between you and the star that makes life possible. It's a distance so great that words like near and far lose meaning altogether. But the story of light doesn't begin in that empty stretch between planets. It begins deep within the sun itself, in a region where light is born but cannot yet move freely. Inside the core, hydrogen atom collide under enormous pressure and temperature, fusing into helium and releasing energy in the form of high-energy photons, gamma rays. These photons are created in unimaginable abundance, trillions upon trillions every second, but none of them escapes quickly. The density of matter inside the sun is so extreme that each photon travels only a few millimeters before colliding with another particle and scattering in a random direction. This process repeats over and over, billions of times. The photon's path becomes a drunken wander through plasma, an endless zigzag journey toward freedom. Scientists estimate that it can take anywhere from 10,000 to several 100,000 years for one of those photons to finally reach the sun's surface. That means the sunlight you see today began its journey long before human civilization existed. Before the pyramids, before writing, before fire was mastered. Some of those photons may have started travelling outward when woolly mammoths still walk the earth. In a way, sunlight isn't just light, it's time itself, released slowly, the product of deep stellar patience. When a photon finally escapes the surface and bursts into space, its journey changes character completely. No longer trapped in chaos, it now races straight and fast, covering 93 million miles of emptiness in those 8 minutes. It doesn't slow down, it doesn't fade or tire, it doesn't need a path or a push. In the vacuum, nothing stands in its way. That relentless speed, constant for every observer no matter their motion, is one of the cornerstones of physics. The speed of light isn't just a number, it's a cosmic limit. The speed at which information, energy, and even causality itself can move. Light defines how we measure everything else. Distances in the universe are so vast that kilometers become useless, so astronomers use the light year. The distance light travels in 1 year, about 9.5 trillion kilometers. When we say that a star is 10 light years away, it means we see it as it was 10 years ago, not as it is now. The further you look, the older the light. In that sense, the universe is a time machine, and every night skies a view into history. But here, closer to home, sunlight plays a more intimate role. It doesn't just illuminate, it sustains. Every plant, every breath of oxygen, every ripple of warmth you feel begins with that 8-minute journey. When sunlight reaches Earth, a small portion of it is absorbed by the atmosphere and the surface, fueling photosynthesis. Chlorophyll, the green pigment in leaves, captures photons and uses their energy to split water molecules, releasing oxygen and storing chemical energy in sugars. Those sugars feed the food chain, which eventually feeds us. Every calorie you consume, whether from fruit, grains, or meat, can be traced back to sunlight. Even fossil fuels buried deep underground are ancient sunlight stored in organic matter that lived hundreds of millions of years ago. The warmth in a room, the flame of a candle, the hum of electricity, they all carry echoes of photons that once left the sun. If you could somehow follow a single photon from its birth in the sun's core to its absorption by a leaf on Earth, it would be like tracing a story of cosmic recycling. That one photon, born from fusion, spends eons escaping the sun, then 8 minutes crossing space, then a fraction of a second transferring its energy to a molecule on Earth. In that moment, its long journey ends, and a new one begins, the chain of life that depends on light. Light also sculpts time as we perceive it. Our planet's rotation turns that steady solar stream into cycles of day and night, which our biology has evolved to follow. When light fades, our brains release melatonin, signaling rest. When it returns, the hormone ebbs and wakefulness rises. Without that pattern, our internal clocks drift. In that sense, light doesn't just illuminate, it regulates. It's a conductor guiding the symphony of sleep, thought, hunger, and alertness. And beyond biology, light shapes emotion. People have long noticed how sunlight affects mood, how winter darkness can bring stillness tinged with melancholy, and how morning light can make even ordinary moments feel like beginnings. That emotional link to sunlight might be one of our oldest instincts. It's built into our memory, language, and culture. Light stands for understanding, hope, clarity, darkness for rest, mystery, or fear. These metaphors aren't coincidences. They come from our dependence on the sun. But sunlight is more than brightness. It's a spectrum. When you pass sunlight through a prism, it splits into the colours of the rainbow: red, orange, yellow, green, blue, indigo, violet. Each colour corresponds to a different wavelength, a different frequency of vibration. Together they form white light, but separated, they reveal the sun's true variety. Beyond visible light, the sun also emits ultraviolet and infrared radiation, invisible to the human eye but vital in their effects. Ultraviolet light triggers vitamin D production in your skin but can also cause sunburn. Infrared light carries heat, the gentle warmth you feel even when the sun is low in the sky. Astronomers study sunlight through spectroscopy, splitting it into its components and examining the dark lines that appear, absorption lines created when specific elements in the sun's atmosphere absorb certain wavelengths. Each element leaves its signature, allowing scientists to determine what the sun is made of without ever touching it. Hydrogen, helium, calcium, iron, carbon. All these fingerprints appear in the sun's spectrum. The same technique works for distant stars. By reading the light, scientists can learn the composition, temperature, motion, and even the age of celestial bodies billions of kilometers away. Light becomes a language, and the universe speaks fluently. If you've ever seen sunlight reflected off the ocean, it might seem like the surface itself is glowing. But what you're really seeing is scattering, photons bouncing from one surface to another, each reflection slightly dimmer, but still carrying the imprint of the original source. That scattering is what gives the sky its blue colour. As sunlight enters the atmosphere, shorter wavelengths, blue and violet, are scattered more effectively than longer wavelengths like red and yellow. Our eyes are more sensitive to blue, so the sky appears that colour. At sunrise and sunset, when light passes through more of the atmosphere, the shorter wavelengths are scattered away entirely, leaving only the longer red and orange hues. The result is a sky that shifts colour not because the sun changes, but because the air does. Light is also the universe's most democratic traveller. It doesn't care about scale or hierarchy. It shines on oceans and deserts, mountaintops and alleys, the faces of kings and children alike. Its constancy is its gift, steady, neutral, abundant. The same sun that warms your hands now also lights the icy plains of Mars and the golden rings of Saturn. The photons that strike your skin might later bounce into space, travel outward for years, and perhaps one day drift past another world entirely. There's something comforting about that quiet continuity. Even when life feels small or temporary, light is shared endlessly, touching everything it can before fading. The measurement of light, how bright, how far, how fast, has long been one of humanity's great fascinations. Early astronomers could only guess at distances, but as instruments improved, so did our grasp of scale. We learned to measure brightness in apparent and absolute magnitudes, to compare luminosities, to map stellar distances using parallax and redshift. Each discovery began with the same basic act: observing light. Even now, with telescopes orbiting far above the atmosphere, every image we capture, every map of a distant galaxy, Every trace of a planet beyond our solar system is made of light. It's our only messenger across the void. Yet for all our precision, there's still something profoundly mysterious about it. Photons have no mass, yet they carry momentum. They can push spacecraft gently through the vacuum using solar sails, propelling them with the faintest but most reliable force in nature. They can pass through space for billions of years unchanged until they meet an atom or a lens or an eye. And they always move at the same speed, regardless of who observes them. That constancy reshaped physics. It's the reason Einstein's theories of relativity exist. The speed of light isn't just fast, it's fundamental. It links space and time, turning them from separate ideas into one connected fabric. So when we ask, how small are we compared to the sun? Light becomes part of the answer. We're small enough that we live on the receiving end of its energy, dependent on the photons that left it minutes ago. Yet we're large enough, conscious enough, to understand what those photons mean, to measure them, interpret them, and use them to build an entire picture of the cosmos. The sun's light is our most immediate contact with the universe, a bridge between immense forces and the tender scale of human perception. You can't hold light, but it holds everything together. It defines the boundaries of vision and the rhythm of time. It carries the story of the sun to the skin of your face and the surface of every leaf. It's easy to take for granted, but every moment of light you see is an interaction between you and a star. The light that fills a room when you open a window is a cosmic handshake, silent but steady, connecting two vastly different scales of being, the incomprehensible and the intimate. If you were to look up tonight, you wouldn't see the sun, but you would see its relatives, other stars sending their own light across space. Some of that starlight has travelled for thousands of years to reach you, and just as the sun's light defines our day, their light defines our night. Each beam, each shimmer, each distant glow is a reminder that light is the one constant in a universe built on change. It crosses distances that no living thing could survive, carrying messages from stars long dead and from others not yet born when their light began to travel. And here we are, small creatures on a small planet, reading that light, building telescopes, writing equations and whispering stories about what we've learned. It's humbling to realize that our entire understanding of the universe, every galaxy, every nebula, every planet we've ever discovered, comes down to how we interpret light. It's the only evidence we have, the only signal that reaches us from across the endless dark. The sun's rays are our nearest sample, the first lesson in a language that extends across the cosmos. So when you feel sunlight tomorrow morning, know that you're part of that exchange. You are both the observer and the observed, both a receiver of light and a source of reflection. The photons that touch you scatter into new directions, carrying traces of colour and warmth into the air, into leaves, into the world. The measure of light isn't just about distance or speed or brightness, it's about connection, how something born in the heart of a star can cross emptiness to reach a single moment of life, and in that moment become meaning. And as we continue this quiet journey through the scale of our world and its star, that meaning will follow us, through distance, gravity, and the fragile beauty of balance. Because every comparison, every measure, every glimpse of proportion begins and ends with light. It is the sun's signature, our inheritance, and the bridge between the vast and the small. If you were to drift far enough into space, until the sun and earth fit together in your field of view, you might notice how delicately the two are arranged. It looks so simple from a distance. One bright star and one small blue world circling it in silence. But every degree, every pull, every turn of that orbit is a masterpiece of balance. The Earth doesn't merely move around the sun, it dances. A quiet, steady motion, ancient and precise, that keeps everything alive. The tilt of its axis, the shape of its path, the rhythm of its spin, all of it forms a choreography so elegant that even the smallest change would unravel the life we know. The first thing to understand is that the Earth's orbit isn't a perfect circle. It's slightly elliptical, meaning there's a point where we're closest to the Sun, called perihelion, and another where we're farthest, called aphelion. The difference between those 2 points isn't dramatic, about 5 million kilometers, but even that subtle variation influences how sunlight spreads across the planet. You might imagine that we'd be warmer when we're closer and cooler when we're farther, but that isn't quite how it works. Seasons aren't caused by distance, they're shaped by tilt. Earth's axis leans about 23.5 degrees relative to the plane of its orbit, and that tilt is what gives us spring, summer, autumn and winter. Right now, as you're listening, the Earth is spinning on that tilted axis like a top that never wobbles out of step. Every 24 hours, it completes one rotation, turning us toward and away from the Sun in rhythm. Every year, it completes one full orbit, travelling about 940 million kilometres in the process. But none of it feels like motion. You don't sense the spin or the speed or the scale of the orbit. You sit still in your room, feeling calm, maybe hearing faint sounds of life nearby, and yet the ground beneath you is moving through space at roughly 30 kilometers per second. You're gliding around the Sun, carried along by gravity's invisible thread, and all of it feels perfectly still. That illusion of stillness might be one of the most remarkable things about life here. The Sun doesn't appear to move because we're caught in its gravity, falling around it endlessly, never hitting the ground because there is no ground to hit. This is what orbit really means. Falling forever but missing again and again. The Earth's path curves precisely at the rate gravity pulls it inward, creating perpetual freefall. That's the dance. A constant surrender to gravity and an equally constant escape from it. If the Earth moved a little slower, it would spiral inward and burn. If it moved a little faster, it would drift outward and freeze. But it moves at exactly the right pace, and so the dance continues year after year for billions of years. It's easy to overlook how fragile that balance is. Every parameter, from the tilt of the axis to the composition of the atmosphere, sits within a narrow range that allows liquid water to exist. The distance from the Sun places us in what scientists call the habitable zone, the region where a planet can sustain oceans without them evaporating or freezing solid. Move Earth just a few percent closer to the Sun, and the increased heat would cause runaway evaporation. Water vapour, a greenhouse gas, would trap more heat, accelerating the process until the planet became a steam-filled inferno like Venus. Move it a few percent farther, and the oceans would freeze, locking the world in ice like Mars. We live inside a narrow band of possibility, a cosmic sliver of temperature and distance that defines what we call home. But even within that band, Earth's climate isn't static. It's a self-regulating system that depends on countless variables: ocean currents, volcanic activity, atmospheric chemistry, and the delicate balance between reflection and absorption of sunlight. Clouds, ice, forests, and deserts all influence how much solar energy the planet holds onto or reflects back into space. When sunlight hits the polar ice caps, much of it bounces away. When it hits dark ocean water or forest canopies, it's absorbed, warming the surface. This interplay keeps global temperature within a range that allows ecosystems to thrive. Disturb that balance too much, and the system shifts. From space, Earth looks serene, wrapped in a thin veil of atmosphere. But that atmosphere is astonishingly fragile. If you were to shrink Earth down to the size of a classroom globe, its atmosphere would be thinner than a coat of varnish. That thin layer is all that stands between life and the vacuum of space. It filters sunlight, traps warmth, shields against radiation, and carries the air we breathe. Without it, there would be no sky, no weather, no sound. Every storm, every breeze, every drop of rain is part of the same system that began billions of years ago when volcanic gases and cometary ice built the first air around a molten world. The Sun's role in this is constant yet dynamic. It bathes Earth in energy, about 1360 watts per square metre at the top of the atmosphere, but that energy arrives unevenly. Near the equator, sunlight strikes directly, concentrating heat. Near the poles, it arrives at a slant, spreading across a larger area and delivering less warmth. The planet responds by circulating air and water, redistributing heat through winds and ocean currents. These global patterns shape weather, climate, and the boundaries of ecosystems. From monsoon rains to polar vortices, it all begins with the way sunlight meets a tilted, spinning sphere. And that tilt isn't permanent. Over long timescales, it wobbles slightly. A slow oscillation called axial precession, caused by the gravitational tugs of the moon and sun. This wobble takes about 26,000 years to complete a full cycle, gradually shifting the timing of seasons relative to Earth's orbit. Combined with subtle changes in the shape of our orbit, these cycles influence ice ages and warm periods. The planet's climate, in other words, is a slow pulse, breathing over millennia, responding to the geometry of its dance around the sun. The moon plays a quiet but crucial role in keeping that dance stable. Its gravitational pull steadies Earth's tilt, preventing extreme variations that would otherwise make the climate far more chaotic. Without the moon, the planet's axis could swing wildly, producing seasons so severe that life as we know it might not survive. The tides too are part of this rhythm, the daily rising and falling of the sea caused by the interplay between the gravitational pulls of the moon and sun. Each tide is a subtle handshake between the two celestial bodies that shape our sky. When you think about it, every sunrise is a kind of miracle of geometry. The Earth's rotation carries you into the light, and for a brief moment, your position in space determines the colour of the world around you. The angle of the sun's rays stretches across the atmosphere, scattering shorter wavelengths and letting longer ones pass, painting the sky pink, orange and gold. That same light continues its path, crossing fields, glinting off rivers, and finally dissolving into shadows again as night returns. From one rotation to the next, the planet turns with such precision that we measure time by it. The day itself is defined by the rhythm of sunlight. If you imagine watching Earth from the vantage point of the sun, it would look like a small marble glowing faintly blue and white, spinning as it moves along its orbit. The continents would drift slowly past, clouds curling across oceans, ice gleaming at the poles. Every 24 hours, it would complete one rotation, and every year, one revolution. You'd see storms swirling, seasons shifting, auroras shimmering near the poles as solar wind meets magnetic field. It would be beautiful in its detail. A planet alive with motion, yet utterly dependent on its distance from you. What's remarkable is how consistent that distance has remained. Despite gravitational influences from other planets and subtle variations in orbit, the Earth's average distance from the Sun, about 1 astronomical unit, has stayed stable enough to support continuous life for billions of years. That's not luck alone. It's the result of physical laws working together in quiet precision. The balance between gravitational attraction and orbital velocity keeps the dance steady, generation after generation. Our ancestors sensed this harmony long before they could describe it mathematically. They built monuments that marked solstices and equinoxes, aligning stones and temples with the path of the sun. To them it wasn't physics, it was reverence. The turning of the seasons was a sacred rhythm, proof that the world was in order. When the sun rose in the same place each year, it meant stability, survival, hope. And in a way, that feeling wasn't misplaced. The Earth's dance around the sun is one of the few constants in an unpredictable universe. Even now, with satellites and equations, we still depend on that constancy. Every orbit determines the calendar, the timing of migrations, the cycles of crops. Our bodies themselves, evolved under this rhythm, carry its imprint. Circadian rhythms, seasonal behaviours, and even our psychological sense of time are anchored to the planet's motion. You could say that our biology remembers the orbit just as surely as the orbit sustains the biology. But the dance is not without vulnerability. The same balance that keeps the planet warm and fertile is sensitive to disruption. Greenhouse gases, deforestation, and industrial activity alter how much sunlight Earth traps or reflects. It's easy to forget that climate is not a fixed condition but an ongoing conversation between the planet and the sun. When we change the atmosphere, we change how that conversation unfolds. The energy that once cycled smoothly between surface and sky begins to accumulate, tilting the balance ever so slightly. The rhythm falters, almost imperceptibly, but the effects ripple through ecosystems, oceans, and weather patterns. Still, even as the Earth warms, tilts, spins, and wobbles, the dance continues. The sun pulls, and the planet responds. The two remain locked in their ancient partnership, a cosmic duet that began long before life appeared and will continue long after it's gone. If you could watch that motion over millions of years, sped up as though time itself were a film, you'd see the orbit trace an elegant ellipse shifting gently, breathing in and out but never breaking the pattern. It's an image of resilience wrapped in fragility. From the surface, though, all of that grand motion condenses into something familiar and comforting. The passing of days and nights, the turn of seasons, the sense of home. You don't have to see the orbit to feel its rhythm. You feel it in the way morning light enters your room, in the way trees bloom and shed leaves, in the way winter makes you seek warmth and summer invites you outside. That's the dance, translated into experience. The cosmic becomes personal without you ever noticing, and that might be the most extraordinary part, that a pattern so vast can feel so human. The same forces that govern the orbit of worlds also shape the timing of your breath, your rest, your life. The sun's pull, the Earth's tilt, the spinning of the globe, they're the hidden metronomes behind everything familiar. You live your days not beside the sun but within its rhythm, carried by a motion so vast that it's both invisible and constant. Somewhere, right now, the Earth is at a particular point in its orbit. On one side of the world it's dawn, on the other, dusk. Somewhere in between, light spills across oceans while stars begin to emerge over cities. The planet moves on, steady and silent, keeping its distance, keeping its balance. And you, tiny as you are part of that same motion. You're not standing still, you're travelling with the Earth, wrapped in the same delicate dance that's been going on for eons. It's humbling to realise that we exist not despite that motion, but because of it. If the Earth didn't spin, there would be no day and night. If it didn't orbit, there would be no seasons. If it didn't tilt, climates would collapse. Every part of what feels ordinary depends on that precise geometry. The Earth's fragile dance around the sun is not just the backdrop to life. It's the structure that makes life possible. And yet, like any dance, it's fleeting. One day, far in the future, the sun will expand, and this rhythm will end. The orbit will shift, the oceans will vanish, and the Earth's graceful motion will dissolve into heat and silence. But for now, in this brief moment of cosmic time, the steps continue perfectly. Each turn, each spin, each rise and fall of light across the sky is the movement of a planet performing a dance older than memory, balanced so delicately that it almost feels inevitable. That inevitability is an illusion, though. It's not guaranteed. It's maintained, constantly, quietly, through the interplay of forces that never rest. And in that balance lies a kind of beauty that numbers can't capture. The Earth, fragile yet persistent, moves not just through space, but through harmony itself. And somewhere within that harmony, we live, breathe, and dream, suspended between light and darkness, always turning, always moving, always part of the dance. If you hold out your hand beneath the sunlight, it feels almost weightless. The warmth is gentle, soft, and so ordinary that it hardly seems capable of anything extraordinary. Yet, What touches your skin in that moment is power. Not metaphorical power, not symbolic warmth, but real, measurable energy. The ongoing release of nuclear fire from a star 150 million kilometers away. We tend to think of light as immaterial, but every beam that strikes you carries weight, however faint, and force, however invisible. It pushes, it presses, and it changes everything it touches. The sun pours out energy constantly. Every second, it releases more than 380 billion megawatts, enough to power human civilization for millions of years. Of that immense outflow, Earth intercepts only a tiny fraction, about 1/2 billionth, and yet even that sliver is enough to drive every weather system, feed every plant, and sustain every heartbeat on the planet. The numbers are staggering, but the sensation is humble. You feel it as warmth on your skin, as a glimmer on water, as brightness in your eyes. The contrast between its scale and its softness might be the purest example of balance in nature. It's strange to think that light, which feels so intangible, can exert force. But it does. Photons, though massless, carry momentum. When they strike a surface, they transfer a minute amount of pressure, what physicists call radiation pressure. It's tiny compared to everyday forces, but it's there. In the vacuum of space, where nothing else interferes, that gentle push can move objects. Spacecraft have used it, unfurling massive reflective sails that catch sunlight like a wind. Each photon that bounces off the sail gives it a microscopic nudge, and over time, those nudges add up. A ship powered by sunlight alone can accelerate continuously, travelling through the solar system without fuel, guided only by the weight of light. That same pressure shapes the universe in quieter ways. It sculpts the tails of comets, blowing dust and gas away from their cores as they approach the sun. It pushes on interstellar dust, carving patterns in nebulae and helping form new stars. Even within the sun, radiation pressure plays a vital role, counteracting gravity's inward pull. Without it, the sun would collapse under its own weight. Every ray of light, every photon emitted from its core pushes outward against the crushing force of gravity, maintaining the delicate equilibrium that keeps the star alive. You could say that light holds the sun open from within, a constant tension between compression and release. Gravity tries to pull the star inward, while radiation pushes outward, and in that balance the sun finds stability. It's an equilibrium so perfect that it's lasted billions of years, and it will last billions more. When we think of the sun as a blazing ball of gas, it's easy to forget that it's also a system in balance, a relationship between opposing forces that never truly rest. When that energy finally leaves the sun and reaches Earth, it transforms everything it touches. The warmth that spreads across a rock, the shimmer on a leaf, the slow evaporation of water from a lake. All of it is sunlight being absorbed, converted, and redistributed. On a molecular level, each photon that strikes matter carries energy in quantized packets. Some are absorbed, raising the energy of electrons within atoms. Others are reflected, scattered, or converted into heat. This constant exchange drives the planet's climate and the chemistry of life itself. To get a sense of how much energy sunlight delivers, consider this. In 1 square metre of sunlight at noon on a clear day, there's about a kilowatt of power. That's roughly enough to run a small heater. Multiply that by the area of the Earth's surface facing the sun, and you get a number almost beyond imagining, about 170 trillion kilowatts of solar energy, arriving at any given moment. Yet the Earth reflects about 30% of it back into space, absorbed unevenly by clouds, oceans, and land. The remaining portion powers the entire biosphere. It's the reason winds blow, rain falls, rivers flow, and plants grow. Without that steady influx, Earth would be a frozen, lifeless rock. There's a quiet irony in knowing that everything familiar, from the rustling of trees to the hum of machines, begins with fusion reactions happening in the heart of the Sun. That energy, generated when hydrogen atoms merge to form helium, converts a tiny portion of mass into energy through Einstein's equation, E = mc2. Every second, about 4 million tons of the Sun's mass vanish, transformed into light and heat. To us, that number sounds enormous, but to the Sun, it's nothing, just a fraction of a fraction. Even after billions of years of burning, it's lost only about 0.1% of its total mass. It gives constantly, endlessly, without diminishing in any way we can sense. That generosity, if you could call it that, defines the Sun's character. It radiates without thought, without aim, without exhaustion. The photons that leave its surface spread in all directions, and a few of them happen to intersect our tiny planet. They fall through the atmosphere, diffuse across clouds, scatter through air, and finally reach the ground, transformed into warmth, growth, and life. You can almost imagine them as messengers, ancient travellers that began their journey long before life existed, carrying the signature of fusion across space. It's tempting to think of light as pure, but it interacts with everything it meets. When sunlight enters the atmosphere, some wavelengths are absorbed by ozone and water vapour. Others are scattered, turning the sky blue and sunsets red. When it hits the ocean, it penetrates to different depths depending on colour. Red disappearing first, blue travelling farthest. The energy that reaches the surface warms the water, drives evaporation, and fuels the planet's weather systems. In the process, the Sun's energy becomes the architect of patterns, from cloud formations to monsoons to the glint of ice on mountaintops. And yet, even as it powers the planet, the Sun's energy is gentle enough to coexist with the fragility of life. The same force that could annihilate worlds is filtered by distance and atmosphere into something nurturing. That filtering isn't accidental. It's a product of billions of years of evolution and balance. The Earth's ozone layer absorbs harmful ultraviolet radiation. The distance from the Sun ensures that the intensity of light is within a range plants and animals can use. It's as though the planet and the star evolved together, fine-tuning their interaction until equilibrium allowed complexity to flourish. But to say the Sun's light is gentle is only true from our perspective. From space, it's relentless. The solar wind, a stream of charged particles flowing outward from the Sun, races through the solar system at hundreds of kilometers per second. It can strip atmospheres, as it did with Mars long ago, or interact with magnetic fields, as it does with Earth, creating auroras near the poles. That same wind, faint though it seems, defines the boundary of our solar system, forming a vast bubble called the heliosphere. Inside it, the Sun's influence dominates. Beyond it, interstellar space begins. Even there, billions of kilometers away, the faint pressure of sunlight persists, extending the Sun's reach across unimaginable distances. It's fascinating that light can both nurture and erode, create and destroy. Too much sunlight and organic molecules break apart, too little and life cannot begin. Somewhere between those extremes lies the narrow window of balance that makes our world possible. Plants evolved pigments precisely tuned to the Sun's spectrum. Animals evolved eyes adapted to the wavelengths that pass most easily through air. Even our sense of beauty, the colours we find calming or vivid, is shaped by sunlight. We see best in the range where the Sun shines most. Our biology is not just illuminated by light, it's sculpted by it. The phrase weight of a sunbeam might sound poetic, but it's literal too. Photons exert pressure measurable in laboratories. A square metre of surface in direct sunlight experiences a pressure of about 9 micronewtons, roughly the weight of a small grain of sand. It's almost nothing, but in space, with no friction, even that can change orbits and trajectories over time. Tiny forces, given enough distance and time, become powerful. The tails of comets, for instance, always point away from the sun not because of wind, but because of light itself. Each photon hitting a dust grain pushes it gently outward, and over millions of kilometres, that pressure reshapes the comet's appearance. The same principle could, one day, carry us beyond the solar system. Scientists have already launched small craft that use light as propulsion, like sails catching a solar breeze. A large enough reflective sail could, in theory, accelerate indefinitely, gaining speed as long as sunlight shines upon it. There's something profoundly elegant about that, travelling through the void powered only by the weight of light. A whisper of pressure from photons, moving a ship through silence. It reminds us that energy and matter are never truly separate. Every interaction between them, from the atomic to the astronomical, is part of the same continuum. The warmth on your skin, the orbit of planets, the flicker of a candle, all are manifestations of the same principles. Light carries energy, and energy shapes matter, and together they form everything we know. Even the thoughts passing through your mind right now, the neurons firing as you imagine sunlight, are powered by the energy that began in a star. The sun doesn't just light your world, it fuels your existence down to the smallest chemical reaction in your cells. If you think about it long enough, that realization becomes oddly comforting. The line between yourself and the sun isn't as wide as it seems. The calories you eat, the breath you take, the warmth you feel, they're all forms of sunlight transformed and repurposed. You are, in a very real sense, made of sunlight stored in matter, released slowly through life. The boundary between your body and the energy that sustains it is fluid. You're not separate from the light that touches you. You're part of its long journey. And though it travels at a speed beyond comprehension, light is patient. It doesn't rush. It simply moves. It leaves the sun, crosses space, touches the earth, and transforms into life, warmth, motion, thought. That transformation is what gives the sun's energy meaning. A photon on its own is just energy. But when it interacts with a leaf, a wave, a human face, it becomes something more. It becomes part of experience. If you could see all the sunlight reaching Earth at once, every beam striking every surface, every reflection, every shadow, it would look like a web of motion, connecting everything to everything else. The planet would shimmer with activity, a living network of light. Each blade of grass, each droplet of water, each breath of wind would be illuminated by energy that began in the heart of a star. The weight of that sunlight, imperceptible as it seems, is what keeps that network alive. You can measure sunlight in watts, in lux, in joules, but none of those units capture its essence. Its true measure lies in the way it shapes time, matter, and consciousness. It defines the rhythm of days, the chemistry of life, the flow of energy from one form to another. Without it, there would be no colour, no warmth, no motion, no awareness. Everything you know is, in some way, an expression of that energy. It's humbling to realise that the same beam of light that feeds a plant could also power a spacecraft or push a comet. That the same energy that warms a morning field could, in another context, vaporise worlds. The difference lies only in distance and perspective. For us it's gentle because we're far away. But that gentleness is deceptive. It's the moderated edge of a furnace, filtered by space and atmosphere into something kind. So when sunlight touches you tomorrow, remember that you're feeling the faintest pressure of an enormous power, the quiet weight of a star's heartbeat, spread thin across space. It's not heavy enough to notice, but it's constant enough to sustain you. That warmth isn't a metaphor, it's the literal trace of fusion, travelling through emptiness to find a home on your skin. And somewhere in that contact, in that exchange between distance and presence, you can feel the scale of things, how small we are beside the sun, and yet how completely we're shaped by it. The weight of a sunbeam may be immeasurable to your senses, but it's everything that keeps the world turning, It's the bridge between nuclear fire and human breath, between cosmic energy and the smallest moment of comfort. And in its steady, invisible way, it holds us all in balance, reminding us that even the lightest touch can carry the weight of the universe. Deep within the sun, far beneath the blinding surface we see, lies a region so extreme that human intuition begins to falter. It's a place of pressure and temperature beyond imagination, a zone where atoms are stripped of identity, where matter and energy blend into something that defies easy description. This is the sun's heart, its quiet engine. Nothing about it is calm by human standards, but its violence is steady, its chaos constant, and that constancy is what allows everything we know to exist. Imagine descending inward through the sun layer by layer. Above, you would leave behind the fiery storms of the corona, the golden photosphere, and the roiling convection zone. The light would dim not because it fades, but because it becomes trapped, scattered endlessly by dense plasma. The deeper you go, the heavier everything feels. At the sun's centre, gravity compresses hydrogen gas to a density 150 times that of water. The temperature rises to around 15 million degrees Celsius. It's here, in this unimaginable furnace, that the process of nuclear fusion takes place. Fusion is the simplest yet most profound mechanism in the universe. In the core, protons, the nuclei of hydrogen atoms, collide at such high speeds that they can overcome their natural repulsion. When they do, they merge to form helium, releasing energy in the process. Each fusion reaction converts a tiny amount of mass into energy, according to Einstein's equation, E mc2. The equation is simple, but its consequences are staggering. It means that a small loss of mass, barely noticeable on a human scale, can produce an enormous amount of energy. That's what powers the sun, a constant transformation of matter into light. Every second, roughly 600 million tons of hydrogen fuse into helium in the sun's core. Of that, about 4 million tons of mass are converted directly into energy. It's a number so large it almost ceases to mean anything, but the result of that conversion is tangible. It's the light that fills your room each morning, the warmth that ripples through air and ocean, the energy that drives weather, biology, and thought. You are, in a literal sense, living on the byproduct of hydrogen becoming helium. The fusion reactions in the sun are part of a process known as the proton-proton chain. It begins with two protons colliding to form a deuterium nucleus, one proton and one neutron, releasing a positron and a neutrino. The deuterium then fuses with another proton to form helium-3, and finally two helium-3 nuclei combine to produce helium-4 and release more protons to continue the cycle. Each step releases energy, and each reaction happens countless times every second. It's a self-sustaining engine, a perfect loop of conversion and renewal that has run for billions of years without pause. The remarkable thing about the sun's core is not just the energy it produces, but how quietly it operates. There's no explosions, no roar, no flicker. It's stable because gravity and pressure remain in balance. If the fusion rate increases, the core expands slightly, cooling and slowing the reactions. If it decreases, gravity compresses the core, heating it and speeding the reactions up again. It's a natural feedback loop, a self-regulating mechanism that keeps the sun in equilibrium. This balance has persisted for nearly 5 billion years, and it will continue for about 5 billion more before the hydrogen in the core begins to run out. It's almost strange to think of something so vast behaving with such delicacy. We often imagine stars as raging fires, but fire is a surface reaction, a brief chemical process consuming oxygen. Fusion is different. It's elemental, occurring at the deepest level of matter itself. The sun doesn't burn, it transforms. What it consumes isn't oxygen, but its own essence. It spends its life converting itself slowly, steadily, into light. The particles born in those fusion reactions embark on a long, difficult journey outward. a single photon created in the core doesn't fly straight to the surface. Instead, it collides with countless electrons and protons scattering in random directions. It may take tens of thousands or even millions of years to travel a distance that light in a vacuum would cross in just a few seconds. Along the way, it loses energy, shifting from the deadly gamma rays of the core to the visible light that warms your skin. By the time it escapes into space, it carries the memory of ages, the product of energy diffused through a star's interior, ancient before it ever touched Earth. You could say that the sun breathed through fusion. Each reaction is a heartbeat, small in isolation but immense in sum. The rhythm is invisible yet unbroken, the steady pulse of a star alive in the silence of space. It's not a living being in the biological sense, but it behaves with the same kind of endurance. The processes within it adjust and respond to conditions, maintaining balance, preserving stability. In that sense, the sun behaves almost like a living system, though it has no consciousness, no will, only physics, operating flawlessly across time. The core of the sun is also a forge. The helium being produced there now is the same element that will, in time, make its way into new stars, planets, and eventually into the molecules of living beings. The elements in your body, the carbon in your cells, the oxygen in your lungs, the calcium in your bones, were all forged in stars that lived and died long before the sun existed. But the helium being made now may one day take part in that same cycle. The quiet engine of the sun is one chapter in the cosmic story of matter, transforming, recombining, and giving rise to new worlds. Every star you see in the night sky is running its own version of that same engine. Some burn faster, others slower, depending on their mass. The smallest red dwarfs can shine for trillions of years, their fusion process is slow and efficient. The largest blue giants burn their fuel in mere millions of years, blazing brightly and dying young. Our sun sits in the middle, steady, patient, moderate. It's not the biggest nor the smallest, but its balance makes it ideal for life. If it were hotter, its lifespan would be shorter. If it were cooler, the habitable zone, that delicate band of distance where water can remain liquid, would be narrower. The sun's moderation is what allows our world to exist in comfort. In the core, fusion produces not just photons but neutrinos, nearly massless particles that barely interact with matter. Trillions of them pass through your body every second, unnoticed. They're ghosts of the fusion process, streaming outward in all directions, carrying information about the reactions deep within the sun. Detecting them is incredibly difficult, but scientists have built vast underground detectors filled with water or special fluids to catch the rare interactions when a neutrino collides with an atom. By studying those interactions, we can peer into the sun's heart indirectly, confirming that our understanding of its quiet engine is correct. It's fascinating that we can learn about something so distant and inaccessible through such subtle evidence. We can't go to the sun's core, and we never will. But by reading its light, by detecting its neutrinos, by measuring its oscillations, we can reconstruct its interior like doctors listening to a heartbeat through a stethoscope. Every tremor, every particle, every wavelength tells a story about what's happening inside, and what's happening inside is astonishingly simple and incredibly profound. Hydrogen fuses into helium, releasing energy. That energy travels outward, heating layers of plasma, driving magnetic fields, producing light, shaping space. From that simplicity comes everything else: the weather, the tides, the breath you just took, all trace back to that one process. It's humbling to realize that such a small-scale reaction, happening in the cores of atoms, can define the shape of planets and the existence of consciousness. If you could somehow slow time to watch the sun's evolution, you'd see the changes unfolding imperceptibly. Over billions of years, the helium produced in the core will accumulate, while hydrogen fusion moves outward into surrounding layers. The core will contract, heating further, causing the outer layers to expand. One day, the sun will become a red giant, its quiet engine transforming into a final blaze before it sheds its outer shell and leaves behind a white dwarf, a dense remnant that will cool slowly over trillions of years. The quiet engine will fade, but its legacy, the light, the warmth, the elements it forged, will endure across the galaxy. It's easy to imagine the sun as eternal because its scale dwarfs ours. Generations rise and fall, civilizations come and go, yet it remains unchanged to our eyes. But from the perspective of the universe, the sun is young and mortal, one among countless others destined to live and die in similar cycles. The difference is that we exist within its lifetime, sharing its stability. We're fortunate enough to be alive during a period when the sun's output is steady and life can flourish. That's not guaranteed forever. It's a temporary alignment of forces, a moment of cosmic calm in an otherwise turbulent history. When you consider that, the idea of the sun as an engine becomes both mechanical and poetic. It's an engine that powers not just itself, but everything that depends on it. It doesn't tire, it doesn't pause, and it doesn't need repair. It's an automatic, eternal-seeming process, driven by the fundamental laws of physics. There's no designer, no operator, no fuel truck waiting in orbit, just gravity, temperature, and time doing what they must. Yet even in that simplicity, there's elegance. The quiet engine within the sun embodies a balance so delicate that if any variable were slightly different, if the density were lower, if the temperature were cooler, if the constants of physics were off by even a fraction, the reactions wouldn't happen. The universe would be dark, filled only with cold gas. No stars, no planets, no life. The fact that fusion works at all is a quiet miracle of physics, one that repeats endlessly across the cosmos. Every time you feel sunlight, you're feeling the echo of that process. The warmth on your skin began as energy released in the core of a star millions of years ago. That photon's journey, from the heart of fusion to the surface of the sun to the air around you, is one of the longest and most patient stories in existence. It's easy to take it for granted because it happens constantly, but when you stop to think about it, there's something almost sacred about that continuity. A process so vast, so ancient, so invisible, sustaining something as fragile and immediate as life. If you could somehow listen to the sun's core, if sound could travel through the vacuum of space, it would be a deep, continuous hum, the vibration of energy radiating outward. That hum would have no beginning and no end, just the steady rhythm of existence itself. The quiet engine doesn't roar, it whispers, and in that whisper lies everything: light, warmth, gravity, motion, life. Even when you sleep, that engine continues. It doesn't wait for you to wake. It doesn't know you exist, but everything you are depends on it. Its fusion reactions keep the balance of energy that lets the earth turn gently through seasons, lets plants grow, lets warmth fill the air. The sun's heart beats constantly, a rhythm so vast it holds entire worlds within it. Somewhere in that stillness, amid the plasma and pressure, hydrogen atoms continue to meet and merge. Each collision is an act of creation, small and silent, but multiplied across space and time until it becomes the universe's most enduring process. That's what powers everything, a quiet engine burning in the dark, transforming simplicity into complexity, matter into meaning, silence into light. And as we continue our slow drift around that star, our small world bathed in its energy, it's worth remembering that we're not separate from that engine. We are, quite literally, part of its output, living traces of its ongoing transformation. The energy that fuels your thoughts right now began in the same place where fusion hums, deep within a sphere of plasma 93 million miles away. That's the connection that binds you to the sun, not metaphorically, but physically. You are powered by the same quiet fire that burns at its centre. The engine will keep running long after we're gone. It doesn't need attention or gratitude. It will keep fusing, keep shining, keep breathing light into the void until its time runs out. And even then, its remnants will continue to shape new stars, new worlds, new forms of life. The quiet engine within doesn't just power the sun, it powers continuity itself. If you've ever watched an eclipse, the kind where daylight dims, the air cools, and the world holds its breath, you've seen one of the most astonishing coincidences in nature. For a few brief minutes, the moon and the sun appear to be exactly the same size in the sky. One, a small rock orbiting our planet, the other, a star 150 million kilometers away. The scale between them is almost beyond belief, yet the alignment is so perfect that one can cover the other completely. In that moment, you can feel the geometry of the universe made visible, the shadow of a small world crossing the face of a giant. It's easy to forget how much our experience of light depends on distance, and how shadows reveal that distance. The sun is so vast that its light, by the time it reaches us, is almost perfectly parallel. That's why shadows cast by sunlight are so sharp and predictable. Every object on Earth, from a pebble to a mountain, traces its outline against that uniform flood of light. Those shadows are, in a sense, the imprint of the sun's scale, a local echo of something enormous and far away. The moon, in contrast, is close enough that its shadow behaves differently. During a solar eclipse, it passes directly between Earth and the sun, casting a narrow path of darkness across the planet's surface. The region of totality, where the sun is completely hidden, is usually only about 100 to 200 kilometers wide. If you were standing outside that path, you'd see only a partial eclipse, the sun as a crescent or a glowing ring. But within the shadow's core, something remarkable happens. The sky darkens in midday, stars appear, animals fall silent, and the sun's corona, the outer halo of plasma, becomes visible, shining in ghostly light. That delicate alignment is possible only because of proportion. The sun's diameter is about 400 times larger than the moon's, but it's also about 400 times farther away. The result is that from Earth's surface, the two appear nearly identical in size. It's a coincidence so precise that if the moon were just a few hundred kilometers farther out, it would never fully cover the sun. Eclipses would still happen, but they would always leave a glowing ring, an annular eclipse, beautiful but incomplete. The fact that we can experience total eclipses at all is an outcome of pure geometry, a fleeting arrangement in cosmic time. The word fleeting matters here, because it won't last forever. The moon is slowly drifting away from Earth at a rate of about 4 centimeters per year. That's roughly the pace at which your fingernails grow, imperceptible on human timescales but profound over millions of years. As the moon recedes, its apparent size in the sky shrinks. Eventually, perhaps 600 million years from now, it will no longer be large enough to fully obscure the sun. The era of total eclipses will end. Future observers, whoever or whatever they are, will see only partial eclipses, never the deep darkness we can witness today. It's strange to realize that we live in a brief window of time when the proportions are just right. We exist in a period when the scale of shadows aligns perfectly. When you think about it, shadows are one of the simplest and most revealing features of light. They show us not just the presence of something blocking illumination, but the nature of the light itself. The sharpness of a shadow tells you how parallel the rays are. The softness of its edges tells you how large or diffuse the source is. Because sunlight comes from a distant sphere, shadows on Earth are crisp and nearly uniform. If you stand in sunlight and raise your hand, the shape it casts on the ground is almost an exact silhouette. That precision wouldn't exist if the sun were much closer or much smaller. Shadows carry information about scale without ever saying it aloud. They also shape our sense of depth and perspective. The contrast between light and shadow defines form, texture, and orientation. The reason you can see the roundness of a face, the shape of a mountain, or the folds of a curtain is because of how sunlight interacts with surfaces. light isn't just brightness, it's the interplay between illumination and obscurity. The sun paints the world not only with colour but with shadow, the subtle gradients that give things dimension. Every leaf, every stone, every line on a hand owes its visible depth to that balance. Without shadows, everything would appear flat, without edges or shape. The entire Earth is, in a sense, a shadowed object, one half always illuminated, the other in night. As the planet turns, the boundary between light and dark, the terminator, sweeps across the surface continuously. From space, it looks like a slow-moving curve separating day from night, a gentle transition that never stops. On one side, dawn begins, on the other, dusk falls. That line is the most tangible expression of our planet's rotation, a visible demonstration of how the sun's light defines time. Every sunrise, every sunset is a shadow's journey across the face of a turning world. Even beyond the Earth-Moon-Sun relationship, shadows play a role in understanding the universe. Astronomers use eclipses, not just solar, but planetary and stellar, to study distant objects. When a planet passes in front of its star, it casts a shadow, detectable from light years away. By measuring the tiny dip in the star's brightness, scientists can infer the planet's size, orbit, and sometimes even its atmosphere. We find new worlds by their shadows. It's an elegant method, using absence to reveal presence. On a larger scale, shadows help us understand light itself. In space, sunlight behaves differently because there's no atmosphere to scatter it. Shadows there are absolute, pitch black, with razor-sharp edges. On the moon, for instance, the contrast between sunlight and shade is so extreme that temperatures can swing hundreds of degrees between the two. There's no air to diffuse the light, no twilight to soften transitions. Step from sunlit ground into shadow, and you move instantly from searing heat to deep cold. It's a reminder that our comfortable experience of daylight on Earth depends on our atmosphere's ability to blur the edges of light. In art and science alike, shadows are how we measure the sun's presence. Ancient astronomers used them to tell time, marking the position of shadows cast by gnomons or obelisks to track the hours. A simple sundial could reveal the Earth's rotation and the sun's apparent motion across the sky. Over centuries, these measurements evolved into the calendars and clocks that organize human life. It's remarkable to think that our very concept of time began with the study of light and shadow. Each passing hour is, in essence, a measurement of the sun's movement relative to our world, or, more precisely, our world's movement relative to the sun. But there's another kind of shadow worth considering, not the ones we see on the ground, but the ones we live within. The Earth's shadow, cast into space, creates the phases of the moon. When the moon enters that shadow, we see a lunar eclipse. In that moment, our planet blocks sunlight from reaching the moon's surface, and a copper-red hue appears as Earth's atmosphere refracts the remaining light. The same geometry that lets the moon hide the sun also allows Earth to cast its own signature into the sky. Two worlds, each capable of shadowing the other, orbiting the same star. A delicate balance of motion and perspective. There's something deeply grounding about the idea that our entire planet has a shadow. We think of shadows as small, personal things. The shape of your body outlined on a wall, the silhouette of a tree on the grass. But Earth's shadow stretches nearly 1 million kilometers into space, a vast cone that moves silently with us through the solar system. Every night, when the moon passes through it, we see evidence of that shadow, proof that even a planet can step briefly out of the sun's light. The scale of shadows, in that sense, becomes a metaphor for scale itself. It's how we understand our size relative to what surrounds us. The sun's light defines the limit of our perception. Its absence defines everything beyond that limit. We live between those two states, between illumination and darkness, between knowledge and mystery. The same star that gives life also casts shadows that remind us of what we cannot see. When you stand under sunlight, your shadow follows obediently, stretching and shrinking as the day moves on. At noon, it's small, huddled beneath you. In early morning or late afternoon, it grows long, stretching across pavement or grass like a quiet twin. That daily rhythm is a small reflection of the larger celestial geometry that governs eclipses and seasons. The position of the sun in the sky, changing through the day and across the year, shifts the angle and length of every shadow on Earth. It's a constant, gentle indicator of our planet's tilt and motion. You could tell time by it, not just by hours, but by the turning of the year. And in that rhythm, there's something reassuring. The same cycles that produce eclipses and tides also shape the simplest experiences. The shadow of a child playing in a field, the shade beneath a tree, the coolness of evening after a long day. The cosmic and the personal are connected through the behaviour of light. What happens on the scale of planets plays out again in the scale of moments. It's fascinating too that shadows can exist only because of contrast. Without darkness, light would have no definition. Without light, darkness would have no meaning. The two depend on each other. The sun, immense and distant, creates both at once: illumination and the absence of it. That duality gives the world texture, rhythm, and depth. It's why we see, why we rest, why life itself develops cycles of activity and sleep. Even the rotation of Earth, creating day and night, is a kind of shadow pattern, half the planet resting while the other half glows. If you could somehow look back at Earth from the surface of the moon during an eclipse, you'd see something extraordinary. You'd see the sun's light bending through Earth's atmosphere, creating a glowing red ring around the planet's dark silhouette. That refracted light is what colours the moon during a total lunar eclipse. Sunlight filtered through air, scattered and softened, wrapping our planet in a halo visible from space. It's one of the few times we can truly see the Earth's presence imprinted on the cosmos, and all of it, every eclipse, every shadow, every soft glow, depends on alignment and proportion. The distances between sun, Earth, and moon must be exact within narrow limits for these events to occur. It's a reminder that even in the vastness of space, precision matters. The universe may seem chaotic, but patterns like these reveal its underlying order. The scale of shadows is not random. It's geometry in motion, harmony expressed through orbit and light. Perhaps that's why eclipses have always affected people so deeply. They feel significant because they are. They're not omens or miracles, but natural consequences of celestial mechanics. Yet the feeling they provoke, that sudden stillness, that collective pause, is real. When the sun disappears and the sky darkens, we're reminded of our dependence on light. We feel the fragility of our world illuminated and shadowed in turn. It's as though the universe briefly reveals its scaffolding, the invisible structure of motion and distance that keeps everything in place. When the light returns, as it always does, we exhale. The rhythm resumes. The shadow recedes into its proper scale, vast in scope yet fleeting in time. But even after it's gone, the memory of that alignment lingers. You carry it quietly, the knowledge that something so enormous can also be so precise, that something so distant can interact with such intimacy. Every day, as sunlight and shadow move across your surroundings, that same pattern continues on smaller scales. The tilt of a branch, the curve of a building, the angle of your own hand, all of them participate in the same dance of illumination and concealment. The light changes hour by hour, and with it, the shape of the world. We live within a moving tapestry of shadows, drawn by a star that seems eternal, but is itself just one actor in an endless cosmic choreography. And somewhere in that play of light and dark lies perspective. The sun is immense, the moon tiny, the earth fragile, yet their interactions create beauty that can be seen and felt. The shadow of one world passing over another can transform the most ordinary day into something unforgettable. It's proof that scale isn't just about size, it's about relationship. The vast and the small meet in the pattern of light and shadow, and through that meeting we understand a little more about where we stand. If you could somehow step outside the solar system and look back, you wouldn't see chaos. You'd see order, not the static kind, but a slow, elegant rhythm, a choreography so vast and intricate that it looks like stillness from afar. The planets, moons, and smaller bodies, all caught in the sun's gravity, move together in a silent harmony. Each follows its own path, its own tempo, but all a part of the same composition. The solar system is not a collection of separate worlds. It's a symphony, each body contributing its own note to the music of space. The sun is the conductor, though not by choice. Its gravity sets the tempo, holding everything in place, defining every orbit. Without that central force, planets would drift into the cold, unstructured void. But because of it, they dance in precise mathematical patterns, each motion predictable yet full of variation. It's difficult to appreciate from here, on one small planet, because the timescales are so different from ours. The Earth completes one circuit of the Sun in a year. Neptune takes 165. The outer planets move so slowly that human civilization could rise and fall several times before they finish a single orbit. And yet, from the Sun's perspective, all of it happens within one continuous rhythm, a vast, unending movement of mass and light. That gravitational rhythm extends far beyond what we can easily see. The Sun's pull keeps the Kuiper Belt in place, a ring of icy debris at the edge of the solar system. Even further out lies the Oort cloud, a spherical shell of distant comets extending halfway to the nearest stars. Each particle there still feels the Sun's gravity, however faintly. It's astonishing to think that a star's influence, born from its mass, can reach for trillions of kilometers and still hold sway. Gravity diminishes with distance, but it never truly disappears. The Sun's silent music plays on, even in the farthest corners of its realm. If you were to map all the orbits, planets, moons, asteroids, comets, you'd see a web of motion, every path looping gracefully around the Sun, none colliding, all governed by the same set of rules. The inner planets move fast, bound tightly to the Sun's warmth. Mercury races around in just 88 days. Venus follows in 225. Earth takes its steady 365. Mars, a little farther out, takes nearly twice that time. Beyond them, the gas giants trace their slower arcs. Jupiter's orbit taking 12 years, Saturn's almost 30, Uranus's 84, Neptune's 165. The rhythm slows as distance grows, but the pattern remains. It's not just orbital motion that creates this symphony. The entire solar system rotates and shifts as one, carried through the galaxy by the Sun's own orbit around the Milky Way's centre. We're not sitting still in any sense. The Sun itself moves at about 230 kilometers per second, dragging its planets along through space. If you could see that motion drawn out behind us, it would look like a vast spiral, the planets looping around the Sun as it races forward, like dancers twirling around a moving partner. We orbit within motion, motion within orbit. It's all movement, but it feels serene because the scale is too large for us to feel. That balance, the way gravity binds everything while allowing freedom, is what makes the solar system so stable. Each planet has found its place, its own distance, where gravitational pull and orbital velocity are in perfect equilibrium. Too close, and it would spiral inward. Too far, and it would drift away. This harmony has persisted for billions of years, and though small perturbations occur, they rarely disturb the overall pattern. It's a kind of cosmic balance that makes music out of mechanics. If you were to listen, though not with ears, but with instruments sensitive enough to detect gravity and radiation, you would discover that space is never truly silent. The Sun itself vibrates, producing sound waves that ripple through its surface. These vibrations are too low to hear, with periods lasting minutes instead of fractions of seconds, but they exist. Pressure waves rolling through plasma. Planets too have their own resonances, as do magnetic fields and charged particles spiraling through space. Jupiter's magnetosphere hums with radio waves. Earth's magnetic field sings with subtle whistling tones known as chorus waves. Even the solar wind carries fluctuations that, when converted into sound, create eerie, shifting melodies. It's not metaphor when scientists speak of the music of the spheres. The universe literally vibrates. Light adds another layer to the symphony. Each planet reflects sunlight differently, depending on its composition and atmosphere. Mercury gleams dully, barren and grey. Venus shines brilliantly, wrapped in thick clouds that scatter light in all directions. Earth glows blue and white, its oceans and clouds reflecting sunlight in dynamic, changing patterns. Mars, rust red and faint, flickers with subtle brightness, changes as dust storms move across its surface. The gas giants shimmer in shades of gold, turquoise and deep blue, their colours sculpted by complex atmospheres. Even Pluto at the outer edge reflects faint sunlight from its icy surface. If you could watch the solar system from afar, it would look like a slow-moving mobile of coloured lights, each orb tracing its path around a glowing centre. And through it all the sun's light travels outward, unbroken, illuminating each world in turn. That light doesn't fade with meaning. It simply spreads, thinning across distance, but never stopping. The same photons that light Earth's oceans also touch the frozen plains of Neptune, the dim rings of Saturn, and the ice of comets drifting in deep space. Each receives its share, each reflects some portion back. The solar system, seen from above, would be full of scattered light, a faint glowing mist of reflections, a soft shimmer against the blackness. Gravity and light are the two main instruments of this cosmic orchestra. Gravity provides the structure, the tempo, the framework that keeps everything in place. Light provides the melody, the visible and invisible flow of energy that gives colour and warmth. The two don't compete, they complement each other. Without gravity, light would radiate into emptiness without touching anything. Without light, gravity's structures would be cold and invisible. Together, they make something complete, form and expression intertwined. What's remarkable is how well the solar system maintains its rhythm without intervention. There's no control centre, no guiding hand. The sun doesn't consciously manage its planets, and the planets don't coordinate their motions. Each simply follows the natural consequence of physics: inertia, attraction, conservation of momentum, and yet the result is harmony. The laws themselves produce balance. It's one of the quiet truths of the universe. That order can emerge from simplicity, that complexity can arise without intention. If you could speed up time and watch the solar system's motion over millions of years, it would look like a great clock, each planet moving in its orbit like a gear, turning slowly but precisely. You'd see the planets align occasionally, form patterns, then drift apart again. You'd see comets sweep in on elongated orbits, flash briefly in sunlight, and retreat to the darkness. Asteroids would tumble through the gaps between planets, some colliding, others slipping into resonance, their periods syncing with Jupiter's gravity. Every motion would be part of a pattern, a choreography too vast to see in real time, but perfect in retrospect. The same harmony extends to smaller scales. The moon's orbit around Earth, Earth's rotation on its axis, the precession of its tilt, the drift of tectonic plates. All of them are motions within motions, synchronized to the larger rhythm of the sun's pull. Even tides, the daily rising and falling of the sea, are a duet between the sun and moon, their gravitational forces combining and opposing in predictable cycles. The Earth breathes through those tides, its oceans pulsing in response to celestial rhythm. In a sense, everything we experience is part of that symphony. the alternation of day and night, the sequence of seasons, the balance of warmth and cold. They're all expressions of celestial timing. The light that filters through your window at dawn, the long shadows of afternoon, the deep stillness of night, each is a note in the same piece. We live inside the music, unaware most of the time that it's playing. The beauty of it lies in its indifference. The universe doesn't compose for us, yet we find music in it. The harmony isn't made to comfort or impress, yet it does. It exists because it must, because the laws of gravity and motion produce relationships that resemble rhythm and pattern. Human perception adds the rest. We give it meaning, calling it music, calling it beauty. But the pattern would continue without us. The orbits would keep turning, the light would keep flowing, the forces would keep balancing. The symphony doesn't need an audience, and yet we are here, able to perceive it. That might be its own kind of participation. By recognizing the pattern, by studying it, by feeling awe in its presence, we become part of the system, conscious observers within the music of matter and motion. Our awareness is another layer of resonance, another instrument in the vast ensemble. When you think of it that way, listening becomes an act of belonging. Even within our own bodies there are echoes of that rhythm. The beating of a heart, the breathing of lungs, the firing of neurons, all operate on cycles of energy and rest, flow and pause, expansion and contraction. Those biological patterns evolved under the sun's steady influence, attuned to the length of a day, the temperature of a season, the predictability of orbit. In every living thing, you can find traces of that cosmic timing, an ancient synchronization between starlight and life. If you were to strip away everything, the noise of civilization, the sound of wind, the movement of water, and somehow experience the solar system as pure motion, it would feel timeless. You'd see spheres circling spheres, all guided by invisible strings of gravity, all radiating light. The inner planets moving swiftly, the outer ones drifting lazily, the sun blazing steadily at the centre. Occasionally, a comet would glide through the inner system, its tail streaming behind it, glowing faintly with reflected sunlight. The pattern would repeat endlessly, neither hurried nor slow. That sense of timelessness might be what draws people to stargazing. When you look up at the night sky, you're glimpsing that larger rhythm, even if you can't hear it. The stars rise and set, the planets drift against the background, the moon changes shape. It's all motion, predictable, patient, reassuring. For a brief moment, looking up, you can feel connected to something immense yet orderly. The same gravitational music that moves Jupiter and Saturn also holds you here, pressing your feet gently against the ground. You're part of the same system, playing your own quiet note, and though we can describe it with equations and simulations, there's something irreducibly emotional about the realization that the universe moves with such grace. The sun doesn't pull randomly, it guides. The planets don't wander aimlessly, they follow. The balance between attraction and motion creates orbits that last billions of years. It's not perfection, but it's close enough that life can exist, that seasons can repeat, that light can return. Somewhere beyond the edges of the solar system, that rhythm fades into the background of the galaxy. The sun's symphony becomes one note among billions in the grander orchestra of the Milky Way, each star with its own ensemble of planets, comets, and dust, each emitting light, each contributing to the overall harmony. The galaxy itself spins, its spiral arms turning slowly around a dark centre. It too is in motion, part of an even larger structure of galaxies drifting together in clusters, all drawn by the faint but persistent force of gravity. The music of space never ends, it only deepens, and yet for all its immensity it still reaches you. Every time you feel sunlight, every time you notice the moon's pull on the tide, every time you watch the stars move through the night sky, you're sensing the edges of that cosmic music. You're hearing in your own way the faint echo of a pattern that stretches from atoms to galaxies. The sun conducts, the planets follow, and we, small, temporary listeners wired, get to witness a few measures of the endless song. The universe doesn't play for applause. It plays because that's what it does. Gravity pulls, matter moves, light radiates, and balance emerges. The symphony of space continues whether we're awake to hear it or not. But knowing that it exists, and knowing that we're inside it, changes how we see everything else. The quiet rhythms of our lives, the pulse, the breath, the turning of a clock, are part of a much larger rhythm, one that began long before us and will continue long after. And somewhere, in that continuity, there's peace, the knowledge that everything, from the orbit of worlds to the warmth of sunlight on skin, is part of a single ongoing harmony. It's not a song with a beginning or an end, it's just the way the universe moves, steady, eternal, and impossibly beautiful. If you could travel outward from the sun, past the glow of the inner planets and into the darker reaches of space, you would start to see how the solar system changes character. The bright warmth of sunlight fades, the intervals between planets widen, and the light begins to lose its intimacy. Out there, between the orbits of Mars and Jupiter, you would find a region that doesn't shine or spin with the confident regularity of a planet. It's quieter, scattered, and filled with remnants. Fragments of stone, metal, and ice that never formed into anything larger. It's a world of dust and pebbles, the leftover debris from creation itself. When we talk about the solar system, it's tempting to focus on the big things, the sun, the planets, their moons. But those are only a small fraction of what actually exists here. The majority of the material floating in our cosmic neighbourhood isn't organised into worlds. It's spread out in belts, clouds, and fields of fragments. Every asteroid, every speck of dust, every wandering comet is a piece of the same story, frozen in place since the beginning. Together they form a vast archive of how the solar system was made. About 4.5 billion years ago, before there were planets, there was only a cloud, a diffuse rotating disk of gas and dust surrounding a newborn sun. Within that disk, tiny grains collided and stuck together, forming pebbles, then boulders, then larger and larger clumps called planetesimals. Most of those merged to form the planets we know today, but not all. Some remained behind, caught between gravitational influences that prevented them from coalescing. The region between Mars and Jupiter was especially affected. Jupiter's enormous gravity stirred the disk like a spoon in water, preventing the material there from ever gathering into a single planet. Instead, it remained a belt of debris, what we now call the asteroid belt. At first glance, you might imagine the asteroid belt as a dense, chaotic place with rocks constantly colliding. In reality, it's mostly empty. The distances between objects are vast, and the total mass of the entire belt is less than that of Earth's moon. If you stood on an asteroid and looked toward the next nearest one, you might not even see it. And yet, within that emptiness, the belt holds incredible diversity. Some asteroids are metallic, composed mostly of iron and nickel, the exposed cores of failed planets. Others are rocky, full of silicates and carbon compounds. Still others are rich in water ice and organic material, remnants of the outer solar system's frozen edges. Each is a time capsule, a fragment of the original building blocks of worlds. One of the most famous, Ceres, is large enough to be considered a dwarf planet. It's round, differentiated, and possibly holds subsurface ice. Others, like Vesta, show evidence of volcanic activity frozen in time. Still smaller bodies, irregular in shape, tumble through space silently, rotating unpredictably as they orbit the sun. Many have moons of their own, tiny companions bound by faint gravity, tracing miniature versions of the larger planetary dance. These objects may seem insignificant compared to planets, but they carry clues about everything that came before. The minerals in meteorites found on Earth, for instance, match the composition of asteroids, confirming that our planet grew from the same raw material. When you hold a meteorite in your hand, you're holding a fragment of the solar system's earliest history, a piece of the dust and pebbles that once orbited a young glowing sun. Between the inner and outer planets, the contrast in composition tells another story. Closer to the sun, temperatures were too high for volatile substances like water, methane and ammonia to condense. So the inner worlds, Mercury, Venus, Earth and Mars, formed mostly from metal and rock. Farther out, where it was cold enough for ices to solidify, different materials could gather. That's where Jupiter, Saturn, Uranus and Neptune formed. Massive planets with thick atmospheres of hydrogen, helium and frozen gases. The boundary between these two regions, known as the frost line, marks one of the great transitions in the solar system, a line separating the rocky inner worlds from the icy outer ones. Beyond the planets, past Neptune, lies another belt of debris, the Kuiper belt. It's colder, darker, and far larger than the asteroid belt. Here, icy bodies drift in orbits that stretch for billions of kilometers. Pluto lives there, along with thousands of similar worlds, Eris, Haumea, Makemake and others, each one distant and dim, yet reflecting faint sunlight like frozen mirrors. Beyond even that lies the Oort cloud, a spherical halo of icy fragments so far from the Sun that it might take a single comet millions of years to complete one orbit. The solar system, viewed as a whole, is less a family of planets than a vast diffuse field of particles, a gradient of matter that thins with distance but never quite ends. All that dust and debris may seem inconsequential, but it shapes everything. Tiny particles drifting through space absorb sunlight and re-radiate heat, subtly altering their orbits through what's known as the Yarkovsky effect. Over time, this can move small asteroids by measurable amounts. Collisions between asteroids generate still more fragments, producing the fine dust that fills interplanetary space. That dust, in turn, scatters sunlight, creating the faint glow known as zodiacal light, a soft triangular shimmer visible before dawn or after dusk in dark skies. It's the sun's light reflected from a haze of microscopic debris, a visible reminder that we live within a sea of dust left over from our formation. Comets, too, are part of this world of pebbles and fragments. They come from the cold outer reaches, their paths elongated and unpredictable. When they approach the sun, heat transforms them. Ices vaporize, releasing gas and dust that form their characteristic tails. Those tails always point away from the sun, blown outward by solar radiation and wind. Watching a comet is like seeing the solar system remember its own past, a piece of ancient ice and rock briefly illuminated before returning to darkness. Some comets deposit their debris in predictable streams, and when Earth passes through those streams, we see meteor showers, streaks of light as dust burns up in our atmosphere. Even shooting stars are part of this same quiet system of motion and residue. It's humbling to realize how small and impermanent even the most familiar things are. The solid ground beneath your feet, the mountains, the continents, all of it began as the same kind of dust and fragments floating around the young sun. Over eons, gravity drew them together, compressing, melting, and reshaping them until they formed a planet. But that process was neither clean nor orderly. It was full of collisions, impacts, and fragmentation. The moon itself was likely born from one of those collisions, a massive impact that tore material from the Earth and sent it into orbit. In a sense, the solar system is still tidying up from its own birth. The dust and pebbles we see today are the leftover clutter of creation, and they still occasionally remind us of their presence when a meteor flares across the night sky. If you could watch the solar system from above, over millions of years, you'd see those fragments moving like glitter in slow motion, drifting, colliding, scattering, and occasionally gathering into larger shapes. Gravity pulls them together, impacts break them apart. It's an endless cycle of construction and destruction, balance and change. Planets seem permanent, but even they began as aggregates of dust, and one day, long after the sun fades, they too will erode, crumble, and return to dust. The solar system began as a cloud, and in time, it will become one again. And yet, within that cycle lies a kind of beauty. Dust and pebbles are not just leftovers, they're the raw material for everything. The same elements that make up the most ordinary rock also form the foundation for life. The carbon in your body, the silicon in computers, the iron in blood and bridges, all of it came from earlier generations of stars, distributed through space as dust, then gathered again by gravity into new worlds. The particles drifting between planets are not waste, they're the substance of continuity. When sunlight passes through that interplanetary dust, it creates patterns we can actually measure. Instruments aboard spacecraft detect the fine particles constantly bombarding them, tiny impacts that reveal the density and distribution of dust throughout the solar system. Closer to the sun, the density increases, farther out it thins, but there is no point where it ends completely. Even beyond the outermost planets, dust drifts, the quiet echo of collisions, the lingering footprint of creation. It's easy to overlook how dynamic that dust is. Some particles spiral inward toward the sun due to the faint drag of sunlight itself, a process called Poynting-Robertson drag. Others are flung outward by radiation pressure, escaping the solar system entirely. Each grain follows its own path, governed by forces both gentle and immense. Taken together, they form a bridge between the planets, an invisible river of motion flowing endlessly around the sun. To the human eye, it's invisible. You can't see it from your window or even from most telescopes. But if you could amplify the light just enough, the space around the sun would glow faintly. A golden haze spread across the plane of the ecliptic. That glow would stretch far beyond the orbit of Earth, past Mars, out toward Jupiter and beyond. It would shimmer faintly in the direction of the sun, like a soft halo marking the path of creation. That's the true appearance of our solar system, not a collection of isolated worlds, but a continuous cloud of light and dust structured by gravity, animated by sunlight. Every spacecraft we've sent into space passes through this world of debris. The Voyager probes, now travelling beyond the outer planets, still encounter the occasional dust grain, tiny impacts that register as brief blips of static in their instruments. The same dust scattered across billions of kilometres connects the inner and outer systems. It's not empty space. It's filled with remnants, quiet and persistent, drifting for ages without direction, yet following laws so consistent that their motion can be predicted for centuries. You could think of it as the solar system breathing. Dust falls inward, vaporizes near the sun, and is replenished by new collisions farther out. Material is exchanged, recycled, and redistributed. The whole system, from the smallest particle to the largest planet, participates in that exchange. Nothing is wasted, nothing is still, and that cycle mirrors what happens on larger scales. Stars form from dust clouds, live their lives, and return their material to space when they die. Galaxies recycle that material, forming new stars and planets in turn. Dust, pebbles, and gas are not the aftermath of creation. They are creation. The sun itself was born from dust that gathered and ignited. The planets formed from dust that stuck together, and when the sun eventually fades, its ashes will become dust once more, ready to seed new worlds elsewhere. The universe builds itself from the smallest things. There's something poetic in that simplicity. We often think of dust as insignificant, as something to brush away or ignore. But in cosmic terms, it's sacred. It's the most fundamental substance of existence. The residue of stars, the potential of planets, the memory of everything that came before. You are, in a very real sense, made of dust. The atoms that form your body were once part of ancient stars, scattered into space, gathered again into the cloud that became the solar system, and eventually formed Earth. You're not just surrounded by dust, you're dust that learned to see the sun. When you stand under a clear night sky and see the faint band of the Milky Way stretching overhead, you're looking through layers of interstellar dust, the same kind of particles that fill our own solar system, only on a grander scale. They block and scatter starlight, shaping what we can and can't see. Even the darkness between stars is not empty. It's filled with dust, faintly glowing, forever moving. So when you think of the solar system, don't picture it as a neat model of perfect spheres and circular paths. Picture it as it truly is, a luminous, dusty expanse full of fragments, reflections, and motion. The planets are simply the largest pieces in an ocean of much smaller ones, and together they create a texture that defines the beauty of the whole. The sun may be the heart of the system, but the dust and pebbles are its memory, preserving the story of where it came from and where it will go. The next time you see sunlight catching in the air, the way dust glows in a beam through a window, think of it as a miniature version of what happens on a cosmic scale. Those particles floating in front of you are, in their own way, part of the same lineage. Light reveals them, warms them, moves them. In that simple moment, you can see the entire solar system reflected. Light, motion, and matter woven together in balance. The world of dust and pebbles is not an afterthought in the story of the sun. It's the background, the foundation, the context in which everything else exists. Without it, there would be no planets, no comets, no life. It's a reminder that even the smallest things matter, that the universe, vast as it is, depends on the tiniest grains to build its grandeur. The sun may be our source of light, but it's the dust that catches that light, scattering it through space, making the invisible visible, turning emptiness into something that glows. If you were to keep travelling outward from the sun, far beyond the orbits of the outer planets, past the frozen objects of the Kuiper Belt, and into the dim borderlands of the solar system, the light would start to fade until the sun itself became just another bright star in a black ocean. From that distance, if you turned back toward home and looked carefully with a sensitive camera, you would see a single point of light. Not a glowing orb, not a sphere, not a landscape, but a speck, faint, bluish, and easily lost in the glare of sunlight. That's Earth, the pale blue dot. That phrase has become something of a symbol for perspective, but it's also a literal description. In 1990, the spacecraft Voyager 1, having completed its grand tour of the planets, turned its camera back toward the inner solar system at the request of astronomer Carl Sagan. From 6 billion kilometers away, it captured a picture that changed how we think about ourselves. Against the vast darkness of space, Earth appeared as a fraction of a pixel, suspended in a sunbeam scattered across the camera lens. That's what we look like from afar, not a grand stage, not a world full of borders and noise, but a tiny mote of colour floating in the infinite. It's easy, from the surface, to forget how small we are. The sky seems large, the horizon endless, the mountains eternal. But distance dissolves those illusions. The further you move from Earth, the more its features fade. The oceans merge into a single glint. The continents blur into smudges of tone, and even the weather, so dominant in our daily lives, becomes invisible. From space there are no cities, no lights, no lines drawn by nations. There's only a disk of swirling clouds and scattered blue framed by the blackness beyond. The blue, of course, is the signature of water. About 70% of Earth's surface is covered by ocean, and sunlight scattered through its atmosphere gives it that distinctive hue. The air bends and filters light, letting blue wavelengths dominate while the deeper blues of the sea absorb and reflect sunlight in shifting tones. From afar, the planet glows softly, like a marble lit from within. That glow is unique. No other known planet reflects light quite like ours. The combination of atmosphere, ocean, and cloud cover creates a subtle shimmer, dynamic, changeable, alive. What's astonishing is that all of human history, every life, every thought, every story has unfolded on that dot. Every language ever spoken, every work of art, every discovery, every conflict and reconciliation, all of it happened in a place smaller than a pixel when seen from the edge of the solar system. The entire sweep of civilization, the rise and fall of empires, the migrations, the songs, the moments of joy and loss, all compressed into a single blue speck hanging in space. From that perspective, even our greatest divisions seem microscopic. There's a quiet humility in realizing that. The light that reaches Earth connects us to the sun, but the reflection that returns connects us to the cosmos. Photons that leave the sun travel for 8 minutes to reach our world, then scatter, bounce off clouds, mountains, and oceans, and some of them travel outward again into space. A few of those stray photons, billions of kilometers away, were caught by Voyager's camera to create that famous image. It means that the photograph itself is a kind of echo. Sunlight reflected by Earth, captured by a machine built by humans, carried across the void, and then transmitted back to us as data. In a sense, it's a conversation between our planet and its creation. That view also reveals something profound about our position. Earth doesn't occupy the center of anything. It doesn't stand apart from the rest of the universe. It's one of 8 planets orbiting an average star in one arm of a spiral galaxy among billions of others. The distances between those stars are so immense that from afar, even the sun becomes a point of light indistinguishable from the rest. And yet, on that small planet orbiting that ordinary star, life exists, complex, self-aware, and capable of wonder. That rarity, that improbable bloom of consciousness, gives the pale blue dot its significance. It's a strange paradox. We're both insignificant and extraordinary. In cosmic terms, our size and influence are negligible. The sun could blink out tomorrow, and the galaxy would carry on unaffected. Yet within our tiny frame, the universe has developed eyes to see itself. Every observation, every question we ask about the stars is the cosmos examining its own reflection. The pale blue dot is not just a point in space, it's the place where matter learned to look back. When scientists analyze light from distant exoplanets, they search for patterns, signs of atmospheres, chemical imbalances, or reflections that might suggest oceans or vegetation. What they're really looking for are echoes of Earth, hints of another blue dot somewhere far away. So far, we've found worlds of gas and rock, heat and ice, but none quite like ours. If an alien civilization were to look at our solar system with powerful instruments, they would notice that one world reflects light in a peculiar way, neither too bright nor too dark, with a distinctive spectral signature of oxygen, water vapor, and chlorophyll. They would know that something unusual happens here. They might call it beautiful. That beauty is fragile. From space, the atmosphere looks like a faint haze, a thin shell of air hugging the surface. It's no more than a few dozen kilometers thick, the boundary between life and vacuum. That delicate film regulates temperature, filters radiation, and sustains every breath we take. It's so thin that if Earth were the size of an apple, the atmosphere would be no thicker than its skin. When you see it from orbit, you realize how precious that layer is, and how vulnerable. The sunlight that sustains life also threatens it, and the balance between the two depends on the chemistry of that fragile air. The pale blue dot isn't just beautiful, it's improbable. For billions of years, countless variables had to align: the right distance from the sun, the right mass, the right mix of elements, the protection of a magnetic field, the presence of water. The chain of coincidences is so specific that it's hard not to feel awe. Out of all the places we know, this small planet is the only one we can call home. Everything we have, everything we are depends on its continued stability. It's humbling to imagine that the same sunlight reflecting off the oceans also touches the frozen moons of Jupiter, the icy rings of Saturn, and the distant haze of Neptune. They too shine faintly in the darkness, but none of them glow with that living blue. The colour of Earth is the colour of chemistry in motion, of ecosystems exchanging breath, of oceans breathing clouds into the sky. It's the colour of time and process, not just of matter. When you look at that tiny dot in the photograph, you're not just seeing a world, you're seeing relationships. Every person who ever lived, every community that ever existed, was bound to that sphere by gravity and atmosphere. Even when we send spacecraft away, they carry pieces of Earth with them, metals mined from its crust, radio signals encoded with our voices, symbols carved by human hands. The universe we explore is always seen through the lens of that home. The pale blue dot isn't only our location, it's our perspective. The image of Earth from space has changed how we think, even if we don't always realize it. The first astronauts to see the planet from orbit described a sense of unity, the sudden absence of borders, the fragility of the thin blue shell, the awareness that everything we fight over exists within one shared sphere. That shift in perspective has a name, the overview effect. It's the emotional response to seeing Earth as it truly is, whole, finite, luminous. From up there, the planet doesn't look like a map divided by colour-coded boundaries. It looks like a single organism, breathing and turning beneath the sun. And yet, it's still easy to forget. From the surface, we live within complexity, cities, noise, weather, movement. The idea of the pale blue dot feels distant, abstract. It takes effort to imagine ourselves from that far away, to compress our scale down to a speck. But that perspective is essential. It reminds us that the scale of our concerns, while meaningful to us, exists within something vastly larger. The storms of daily life are local weather on a planet drifting peacefully through cosmic calm. What's remarkable about the pale blue dot image is that it wasn't taken for science. It wasn't a measurement or a data gathering mission. It was a gesture, an act of curiosity and humility. When Voyager turned its camera back toward home, it was already on its way out of the solar system, past the point of no return. Its instruments were aging, its power limited. But that one picture, captured just before its cameras were shut down forever, became one of the most profound images ever made. A farewell photograph from the edge of sunlight, a reminder that even as we reach outward, we remain tethered to a single point of origin. The spacecraft itself is still travelling, drifting into interstellar space. It carries a golden record, a time capsule containing sounds, music, and images from Earth. Greetings in dozens of languages, the laughter of children, the songs of birds, the sound of waves, the pulse of the human heart. It's unlikely anyone will ever find it, but that isn't the point. It's an offering, our small signature, our acknowledgement of belonging to something greater. The record contains, among other things, a simple drawing showing the position of our sun among nearby stars. If someone were to follow that map, and if they could see the same pale blue dot we see, they would find us. There's something beautifully paradoxical about sending such a message into space. We know how small we are, and yet we reach outward. We know the odds of being noticed are almost zero, and yet we send our voices anyway. It's an act of hope, not hope for rescue or recognition, but hope that existence itself is meaningful, that even a tiny speck can contribute something to the universe's story. Sometimes when you step outside at night and look up, it's easy to forget that you're standing on that same dot, spinning silently in the dark. The air around you is the same air that wraps the whole planet. The light you see from the stars is the same light that falls on the oceans and mountains. You're not separate from it. you're part of the same continuum, a living being on a small glowing world suspended in sunlight. From that perspective, the phrase pale blue dot becomes less about smallness and more about connection. It's a reminder that we're participants in something vast but coherent, a structure of motion, light, and gravity that extends outward without end. We may never leave this planet in body, but in thought and observation we already have. Every image from a telescope, every probe sent outward, every equation written about the cosmos is an extension of our curiosity. The same curiosity that made us turn a camera back toward home is what drives us to understand everything beyond it. The image of Earth from that distance doesn't diminish us. It clarifies us. It shows us that we are not the centre, but we are also not irrelevant. The scale may make us small, but our ability to comprehend that scale makes us unique. We can understand the sun, the planets, the dust and light that surround us, and in that understanding we find belonging. One day, long after Voyager has fallen silent, other spacecraft will carry that same curiosity farther. They will send back new images, perhaps of distant stars, perhaps of new pale blue dots circling them. Each will remind us of the same truth, that light and life are bound together, and that even the faintest speck can contain entire worlds of meaning. When you imagine Earth from that distance, floating in darkness, surrounded by the quiet hum of the solar system, it's hard not to feel a sense of calm. The chaos of life recedes, and what remains is a single sphere turning in sunlight, carrying every story ever told. The pale blue dot is not just a photograph, it's a mirror. It shows us who we are, temporary, fragile, luminous, moving through space on a world that, in its smallness, contains everything. If you could drift far enough into space that the sun was no longer blinding, you might begin to see it as it truly is. Not the centre of everything, not a unique flame burning alone, but one among countless others. A single star in a galaxy full of stars, each shining with its own quiet persistence. From Earth, the sun feels singular, irreplaceable, the source of light and life itself. But in the wider cosmos, it's one point in an ocean of fire, one instrument among billions in the endless symphony of the light. When you look up at the night sky, you're seeing what the sun would look like from somewhere else. Every star you see is another sun, some smaller, some larger, some older, some newly born. The faint ones might be dim dwarves barely holding themselves together. The bright ones could be giants burning through their fuel in a few short millions of years. And between them, countless others lie hidden beyond the reach of your eyes, scattered across the vast plain of the Milky Way. It's hard to imagine such abundance. We live beside a single star, but we belong to a galaxy that contains hundreds of billions. The sun sits about halfway out from the centre of the Milky Way in one of its spiral arms, a region filled with gas, dust and other stars. From there it orbits the galactic centre at a speed of about 230 kilometers per second, taking roughly 225 million years to complete one lap. That means the last time the sun was in this position, dinosaurs walked the Earth. By the time it finishes another orbit, whatever follows humanity may be something entirely different. The sun's path through the galaxy is long, smooth and cyclical, a slow motion that continues unnoticed while we measure time in years and days. The sun itself is an ordinary G-type main sequence star, the kind astronomers sometimes call a yellow dwarf, though in truth its light is white, only appearing yellow through the filter of our atmosphere. It's not the biggest, not the hottest, not the most luminous. It's average in almost every way, and that ordinariness is what makes it extraordinary for us. If it were larger, it would burn too fast. If it were smaller, it might not provide enough energy to sustain the kind of world we live on. It exists in a middle range, a balance point in the spectrum of stellar possibilities. Stars like the sun spend most of their lives in stability, fusing hydrogen into helium in their cores, maintaining a steady brightness for billions of years. It's that long lifespan that allows planets like Earth to evolve and thrive. Larger stars, though magnificent to see, burn out quickly. A massive blue star may shine 1,000,000 times brighter than the Sun but live only a few million years before collapsing or exploding. Smaller stars, red dwarfs, burn dimly, but for trillions of years they're like too weak to sustain planets in the same way. Our Sun, by comparison, is a calm middle note, warm enough, stable enough, enduring enough for life to take its time. From a distance, if another civilization existed around a nearby star, they might see our Sun as just one more point of light. Its brightness, colour and spectrum would tell them it's a moderate, long-lived star. They might infer that it could host planets, and perhaps some of those planets might hold water or life. But it would be to them one among many. The same way we look at the stars of Orion, Cassiopeia, or the Southern Cross without realizing that some may have their own inhabited worlds, they would look at our Sun as just another gleam in the dark. There's a humility in that thought, that what feels central to us is peripheral to the universe. Yet there's also comfort in it. It means the processes that gave rise to us aren't unique. The physics that formed our Sun operate everywhere, shaping stars and systems throughout the cosmos. The light that warms your skin is born from the same kind of reactions happening in countless other stars. The laws that govern our Sun's fusion, gravity and radiation are universal. We are local participants in something infinitely shared. If you could step back and see the Sun alongside its nearest neighbours, it would form part of a loose community of stars, a local neighbourhood in galactic terms. The nearest is Proxima Centauri, a small red dwarf just over 4 light-years away. It's part of the Alpha Centauri system, which includes 2 larger, Sun-like stars orbiting each other. Around Proxima, astronomers have discovered at least one planet, perhaps rocky, perhaps within a habitable zone. It's strange to imagine that there may be another world circling that tiny dim star where sunlight, different, cooler, redder, shapes another kind of day. Our Sun's neighbourhood extends in all directions. Sirius, the brightest star in our night sky, blazing twice the Sun's temperature. Epsilon Eridani, a slightly younger and smaller star with its own debris disk. Tau Ceti, another Sun-like star with planets that may orbit too close or too far for life. There are hundreds of stars within a few dozen light-years, each with its own motion, its own system, its own potential. To the galaxy, they are countless points. To us, they are the nearest examples of the possible. What's fascinating about stars is how they connect through cycles of birth and death. Every star begins in a cloud of gas and dust, a nebula, where gravity gathers matter into a dense core. When the pressure and temperature become high enough, fusion begins and a star is born. It shines for millions or billions of years, then dies, returning its material to space through gentle shedding or violent explosion. That material, hydrogen, helium, carbon, oxygen, iron, becomes part of new clouds, forming new stars and planets. The Sun itself was born from such a cloud about 4.6 billion years ago, enriched by the remains of older stars. In that sense, our star carries the history of many before it. When it eventually dies, the process will continue. Billions of years from now, after it exhausts its hydrogen and expands into a red giant, the Sun will shed its outer layers into space, forming a glowing shell of gas, a planetary nebula. At its centre will remain a white dwarf, a small dense remnant no larger than Earth but containing most of the Sun's mass. It will cool slowly over trillions of years, fading into darkness. The elements expelled into space, carbon, oxygen, nitrogen, will drift outward, perhaps someday joining new clouds, new systems, new life. This cycle will continue, unbroken. It's humbling to realize that even stars die. They seem eternal to us because our lifespans are so short by comparison. But in the grand rhythm of the galaxy, stars are temporary. They live, they shine, they fade. The Milky Way is full of both newborn stars still forming in bright nurseries, and ancient ones nearing the end of their light. When you look at the night sky, you're seeing that entire timeline at once. Youth and age, creation and decay, all shining together. The sun's light, steady and warm, sits somewhere in the middle of that continuum. From the surface of Earth, it's difficult to comprehend how many stars exist. The unaided human eye can see perhaps a few thousand on a clear night, but that's only the faintest hint of what's out there. In our galaxy alone, there are hundreds of billions. Beyond that, there are billions of galaxies, each with their own stellar populations. The numbers grow until they stop being numbers and become texture, a background of light that extends without edge. Against that background, the sun is less than a grain of sand, and yet that one grain has meaning to us. It's the star we know best, the one whose light defines our sense of time and existence. It's our local example of the universal phenomenon we call starlight. Every equation we've written about the life cycles of stars, every measurement of luminosity or temperature, every discovery about galaxies, all of it begins with studying our sun. It's the reference point, the key in which the symphony of the universe is written. Sometimes astronomers describe stars by their spectral type, letters and numbers that classify them by temperature, colour and size. O, B, A, F, G, K, M. O-type stars are hot, blue and massive. M-type stars are cool, red and small. The Sun, a G2V star, sits right in the middle. Yellow-white, moderate in size, main sequence, stable. Only a small percentage of stars are like it. Most are dimmer, cooler and smaller red dwarfs, which make up nearly 3/4 of the galaxy's stellar population. The rest, the bright giants and supergiants, are rare but luminous, visible across great distances. If you were standing on a planet orbiting another star, say a red dwarf, your sunlight would be dimmer and redder. Shadows would be softer, days cooler. Plants, if they existed, might evolve to absorb infrared light instead of visible light, appearing darker to your eyes. If you lived near a blue giant, your days would be bright and short, your seasons compressed into a fraction of Earth's timescale. The sun's golden light is specific to its temperature, to its balance of heat and distance. The colour of daylight here is the colour of home. When you think about it, the sun among stars isn't remarkable in its properties, but in what it has enabled. Around this average star in one small orbit, conditions align to produce liquid water, an atmosphere and life that can reflect on its own origins. That's the quiet miracle, that something so typical could host something so rare. There may be countless other stars like it, but for us this one is personal. Every sunrise and sunset, every shadow and reflection is shaped by this particular point of light. If the sun were to vanish, its light would continue travelling for 8 minutes before the darkness reached us. After that, the planets would continue in their orbits for a short while, following inertia, before gravity's absence changed everything. The solar system would scatter, its harmony dissolved. It's a reminder that for all the sun's ordinariness, it's also indispensable. Without it, there would be no warmth, no motion, no anchor. We owe everything, literally everything, to its presence. And yet it doesn't know we exist. It shines because that's what stars do, not because we need them to. It gives without awareness, and in that indifference lies a kind of purity. The sun doesn't discriminate or favour. Its light falls equally on oceans and deserts, forests and cities, mountains and skin. Its constancy is the quiet foundation beneath all life, and that constancy links it to every other star. Each one shines in the same way, following the same physics, unaware of who or what might be watching. If you could line up the stars of the galaxy like notes on a staff, the sun's tone would blend seamlessly among them. neither the highest nor the lowest, but steady, familiar, balanced. It would be one sound among countless others, contributing to the great hum of the cosmos, and yet, to us, that sound is everything. It's the rhythm that shapes our days, the warmth that sustains our blood, the light that fills our eyes. The sun may be average, but for us it's the most beautiful star in existence. There's comfort in that duality, knowing that we live beside something both ordinary and irreplaceable. The sun's ordinariness ties us to the universe. Its importance ties us to life. We exist at the intersection of those two truths, small but luminous, temporary but aware. The same fusion reactions that power our sun happen in stars scattered across the Milky Way and beyond, linking us through time and space to everything that has ever shone. When night falls and you look up at the stars, remember that they're all suns. Each one has its own story, its own planets, its own possible observers looking back. Somewhere, perhaps another world orbits another star, and someone there wonders if they too are alone. From their perspective, their sun would be the centre of everything, and our sun, faint and distant, would be just another point of light. The universe is full of centres, each defined by its observers. The sun among stars is both unique and universal, one light in a galaxy full of them, each shining, each sustaining, each marking its place in the infinite dark. And if you think of it long enough, that thought becomes strangely peaceful. The sun doesn't need to stand apart to matter. It matters precisely because it belongs, because it's part of a vast connected network of light, each star echoing the same processes, each contributing to the same cosmic balance. The sun is not special, and that's what makes it beautiful. It's the ordinary miracle that makes all the others possible. If you could look at the Milky Way from far above, from some quiet point outside its spiral arms, it would appear as a luminous whirlpool suspended in darkness, a great rotating sea of stars, gas and dust, glowing faintly in hues of blue and gold. Its light would seem smooth at first glance, but if you looked closer, you'd see that it isn't a solid glow. It's made of countless points of radiance, each one a sun, each one surrounded by its own system of planets and debris. Together they form an ocean of stars so vast that even light, travelling at nearly 300,000 kilometers per second, would take 100,000 years to cross it. That's our home galaxy, the Milky Way, and our sun, the great fire that defines our days, is just a single wave within it. From Earth's surface, on a clear night far from city lights, the Milky Way stretches across the sky as a pale, misty band. It looks delicate, almost transparent, like smoke against the dark. But that mist is an illusion created by distance. You're looking edge-on through one of the spiral arms, seeing billions of stars so tightly packed from our perspective that their light blends into a continuous glow. Each faint patch, each curve of brightness, is filled with worlds you could spend a lifetime counting and never finish. Our sun is about 26,000 light-years from the galactic centre, near the inner edge of a spiral arm known as the Orion Arm. The Milky Way itself is a barred spiral galaxy, its central region shaped like a bar from which the arms curve outward like waves. Those arms are not physical structures in the way a solid object has edges. They're density waves, regions where stars and gas bunch together temporarily as they orbit the centre, like traffic slowing and speeding along a highway. Stars pass in and out of them over millions of years, caught briefly in the spiral before continuing onward. The galaxy, for all its appearance of solidity, is in constant motion. Everything within it moves. Stars orbiting the centre, gas clouds drifting and colliding, dust gathering into new systems. Even the galaxy itself rotates, turning slowly as a whole, taking about 250 million years to complete one revolution. That means the sun has circled the galactic centre roughly 18 times since its birth. Each orbit carries us through different neighbourhoods of the galaxy, regions dense with stars, others sparse and dim, some rich in heavy elements, others composed mostly of hydrogen and helium. The solar system, small and self-contained, sails quietly through this ever-shifting sea. At the heart of the Milky Way lies something invisible yet immensely powerful, a supermassive black hole known as Sagittarius A. It contains about 4 million times the mass of the Sun, compressed into a region smaller than our solar system. It doesn't shine, but its presence can be felt in the way stars near the centre move, whipping around at tremendous speeds, bound by gravity's invisible grip. Around it, the central bulge of the galaxy glows with densely packed stars, ancient and yellow. Farther out, the spiral arms contain younger, bluer stars, regions of active creation where new suns are born from clouds of gas. Those stellar nurseries are among the most beautiful places in the galaxy. Giant molecular clouds, stretching across light years, collapse under their own gravity, forming clusters of new stars. Ultraviolet radiation from the youngest, hottest of those stars illuminates the surrounding gas, creating nebulae, vast colourful structures that we see as pinks, blues, and reds in telescope images. The famous Orion Nebula, visible even to the naked eye as a faint patch in Orion's sword, is one such region. There, hundreds of new stars are being born, their light carving cavities in the surrounding cloud. The same kind of region once gave birth to our Sun. The scale of all this is difficult to imagine. Between stars, the distances are measured in light years. The distance light travels in a year, about 10 trillion kilometres. Even the nearest star to us, Proxima Centauri, is over 4 light-years away. The Milky Way's disk, by comparison, is about 100,000 light-years across, and surrounding that disk is a vast halo of dark matter, an invisible structure that outweighs all the stars combined. We can't see it directly, but we can measure its effect on the motion of the galaxy. It's the unseen framework holding everything together, the silent gravity beneath the luminous surface. When you look at the Milky Way in the night sky, you're seeing the cross-section of that immense structure. The dark streaks that divide its glow are lanes of interstellar dust, tiny particles of carbon, silicon and ice that absorb and scatter light. They mark the boundaries of clouds where new stars will eventually form. In a sense, the Milky Way is both an ocean of light and a landscape of shadow. The balance between the two gives it texture, depth and motion. Every star in that ocean has its own story. Some are older than the galaxy's spiral arms, relics from its earliest days. Others are newborn, their planets still forming. Many exist in pairs or groups, orbiting each other in delicate gravitational dances. Some end their lives quietly, fading into white dwarfs. Others die violently, exploding as supernovae and scattering their enriched material across space. Those explosions seed the galaxy with heavy elements. The iron in blood, the calcium in bones, the gold in rings, all forged in the hearts of stars and released in their deaths. The Milky Way is a factory of matter, a place where creation and destruction are two sides of the same process, and through it all, our Sun travels along its orbit, carrying Earth and its companions with it. From our perspective, everything feels fixed. The constellations, the seasons, the familiar patterns of the sky. But over long timescales, even those patterns shift. The Sun moves relative to other stars, changing our view of the night sky slowly, almost imperceptibly. 100,000 years from now, the constellations we know today will be unrecognizable. The galaxy is dynamic, alive with motion, even if we experience it as stillness. There's something profoundly peaceful about that. To know that we are adrift in a galactic ocean, moving with it, part of its flow. We're not outside observers, we're passengers within the current. The atoms in our bodies once belonged to ancient stars, and the light that warms our world travels through the same medium that will someday carry new suns into being. The Milky Way isn't just our location, it's our origin and our future. If you could see the galaxy's disk from the side, it would look thin and delicate, only 1,000 light-years thick compared to its enormous width. That thinness comes from rotation. As the galaxy spins, gravity pulls material into a flattened shape, much like a spinning pizza dough spreads into a disk. The spiral arms trace the pattern of density waves moving through that disk, and within those arms, stars form, shine, and fade. The edges of the galaxy are faint, the light thinning into the dark halo. Beyond that halo, intergalactic space begins, vast, cold, and nearly empty. The Milky Way drifts there like an island surrounded by an endless sea. And it's not alone. Nearby, the Andromeda galaxy approaches, drawn by mutual gravity. In about 4 billion years, the two will merge, their stars passing mostly without collision but reshaping both galaxies into a new, larger form. It's a slow and silent process, one that will unfold long after the Sun has entered its final stages. But the motion has already begun. Even now, the faint tug of Andromeda's mass influences the Milky Way's future. The universe, on every scale, is about connection. No object truly isolated, no system untouched by others. The stars we see at night are only the nearest part of that connection. Beyond the reach of the naked eye, billions more fill the galaxy, each separated by enormous distance yet bound together by gravity. The light from those stars travels for thousands of years before reaching us, carrying messages from the past. When you look at the Milky Way, you're seeing ancient light, photons that left their sources long before humanity existed. The glow overhead is history, still arriving, still whispering the story of where we come from. It's strange to think that, as immense as the Milky Way is, it's not unusual. It's one galaxy among billions, each with its own shape, size, and structure. Some are spirals like ours, others are elliptical, irregular, or distorted by gravitational encounters. Together they form clusters and superclusters, vast filaments of matter stretching across the universe like threads in a cosmic web. The Milky Way is just one node in that network, moving quietly through its local group of companions. From far away, it would look like a tiny patch of light among many others, blending into the background of the cosmos. And yet, from within, it feels endless. The distances between stars are so great that even light seems slow. A radio signal sent from Earth to the nearest star would take over 4 years to arrive. Travelling there with current technology would take tens of thousands of years. The scale of the galaxy isn't something we can traverse, only imagine. But imagination is powerful. It allows us to perceive what we can't experience, to see the ocean we're floating in without needing to cross it. When you lie under a dark sky and see the Milky Way stretching above, you're not just looking at distant stars. You're looking through the structure that defines our cosmic home. That light, soft and continuous, connects you to everything else that has ever existed here. The photons striking your eyes tonight may have left their sources when the first humans learned to make fire, when continents were still shifting, when life was just beginning to take shape in the sea. The Milky Way's ocean carries the past within its light. It's easy to feel small when you think about these distances, but smallness isn't insignificance. On the contrary, our ability to understand the galaxy, to measure its motion, to see its structure, that's an extraordinary achievement. We've learned to read the ocean from within it, to recognize patterns in the waves. Through telescopes and instruments, we've mapped the positions of stars, traced the arms of the spiral, identified the central black hole, and even measured the invisible halo of dark matter. We can't leave the galaxy, but we can see it. We can know it. The Milky Way's beauty lies in its motion, the slow, ceaseless turning of its arms, the births and deaths of stars, the balance between gravity and expansion. It's a dynamic system, but also a stable one. The forces that govern it are constant, predictable, timeless. Gravity binds, light reveals, time transforms. That rhythm plays out everywhere, from the heart of the galaxy to the smallest atom. The same laws that hold the stars in their paths also hold the molecules in your body together. The connection isn't poetic, it's literal. You're made of the galaxy, built from its materials, sustained by its energy. When you picture the Milky Way as an ocean, it's not a metaphor for chaos. It's a description of continuity. Waves rise and fall, but the ocean remains. Stars form and fade, but the galaxy endures. And within that endurance, life appears, asks questions, and briefly becomes aware of the whole. The Milky Way doesn't know we exist, but through us it becomes visible to itself. We're the small awareness within the great current, the quiet moment of reflection within the vast flow of light. From a distance, our sun would blend into the background, one drop among billions. But from here, that drop defines our entire world. It reminds us that even within infinity, there can be intimacy, a connection between a single star and the beings who depend on it. The Milky Way's ocean contains everything that has ever been, but it also holds us right now, turning gently beneath the starlight, carried along by gravity's steady hand. And if you could listen closely, not with ears, but with understanding, you might hear the faint hum of it all, the low steady vibration of stars orbiting, of gas clouds collapsing, of light crossing emptiness. It's not a sound, but a rhythm, a continuity that never ends. The Milky Way's ocean isn't silent. It's simply too vast for its music to reach us in any familiar way. But it plays, always, everywhere, and we are part of its movement. If you stand beneath a dark sky long enough, your eyes begin to adjust to the faintest light. The Milky Way emerges slowly, like breath condensing in cold air, stretching across the sky in soft, dusty light. At first it feels endless, but as your eyes adapt, you begin to sense boundaries, not literal walls, but limits to what you can perceive. The stars thin out at the horizon, their light diffused by the air, and beyond them lies something you cannot see. It's not darkness, not exactly. It's distance. It's the edge of perspective. Perspective is a strange thing in space. It's not about where you stand, but how far light has travelled to reach you. The further away something is, the longer ago you're seeing it. Every point of light in the night sky is a memory, a glimpse of the past still on its way to you. The farther you look, the older the light becomes, until eventually you're not just looking into space but back through time itself. That's what makes the cosmos feel infinite. Not because it has no end, but because the light within it is still unfolding. If you could see beyond the Milky Way, your view would open into an even grander scale. You'd see other galaxies scattered across the darkness, each one a swirl of light containing billions of stars. Some would appear as faint smudges, others with powerful enough eyes would reveal structure, spirals, ellipses, irregular forms twisted by gravity. Every one of those distant glows is a complete universe in miniature, with its own suns, planets, and histories. Between them stretches vast space, cold, nearly empty, but still filled with the faint whisper of radiation and the occasional drifting atom. Our nearest galactic neighbour, Andromeda, lies about 2.5 million light-years away. When you see it through a telescope, the light you're looking at left long before modern humans existed. It travelled patiently across the void, through the invisible fabric of time, to arrive in your eyes. It's a small, steady reminder that seeing is never instantaneous, that vision in the universe is always delayed. The stars and galaxies you admire tonight may already have changed or even disappeared. What you witness is their ghost, their light still crossing the vast distance between their past and your present. Andromeda isn't alone. The local group, a cluster of nearby galaxies that contains dozens of members, small dwarfs, satellites, and faint companions orbiting larger galaxies like the Milky Way. Beyond that lies the Virgo cluster, a dense region of thousands of galaxies bound together by gravity. Beyond that still, there are superclusters, enormous webs of galaxies stretching across hundreds of millions of light years, interconnected by filaments of dark matter and separated by immense voids. The deeper we look, the more structure we see. Patterns emerging from apparent chaos, connections forming across incomprehensible scales, and yet even those enormous structures exist within a horizon. The observable universe, the part we can see, extends about 46 billion light-years in every direction. Beyond that, there's more universe, perhaps infinite, but light from those regions hasn't had time to reach us since the beginning of everything. We live inside that boundary, not as a physical wall, but as a limit of knowledge. The edge of perspective isn't the edge of existence, it's simply the edge of what we can perceive. The reason there is such an edge lies in the nature of light and time. The universe has a finite age, about 13.8 billion years, and because nothing can travel faster than light, there's only so far we can see. When astronomers point telescopes toward the distant past, they're looking at younger versions of the cosmos, galaxies forming, stars igniting, the first clusters coming together. With instruments tuned to infrared and microwave light, they can even glimpse the afterglow of the Big Bang itself, the cosmic microwave background. It's faint, uniform, and ancient. Light emitted when the universe was only 380,000 years old. It's the oldest photograph in existence, the true boundary of sight. Beyond that, there is no light we can detect. When you consider that, the scale becomes almost overwhelming. We exist on a small planet orbiting an ordinary star, inside a galaxy that's one of billions, in a universe that may have no edge at all. And yet within that immensity there's a clear frontier, the horizon of our understanding. We can't see beyond it, but we can imagine. That act of imagining is itself an extension of perspective. We use mathematics, theory, and observation to peer past the limits of light, constructing models of what might lie beyond. The edge of perspective moves as our instruments improve, but it never disappears entirely. There will always be more beyond what we can reach. In a way, the boundary of perspective defines who we are. Every generation of explorers and scientists has pushed it outward, building better tools to see deeper, farther, older. Galileo pointed a small telescope at the sky and found that the Milky Way was made of stars. Edwin Hubble looked through a larger one and discovered that there were galaxies beyond our own. The Hubble Space Telescope, centuries later, revealed that even the darkest patch of sky, when magnified, was filled with thousands of galaxies. Each discovery widened the horizon, but none erased it. The more we see, the more we realize how much remains unseen. Perspective also shapes how we understand our place within all this. From Earth, the universe seems centered around us because we see everything radiating outward from where we stand. But there is no true center. Every observer, no matter where they are, experiences the same expansion of space, the same cosmic horizon. That means every point in the universe is from its own view the middle of everything. The edge of perspective is not a border you can approach, it's a limit that moves with you. Wherever you stand, the universe stretches equally in all directions. That symmetry is one of its quiet wonders. Everything, everywhere, feeling equally at home in infinity. It's humbling to think about, but also deeply human. We build meaning through perspective. The night sky's the same for everyone, but each person sees it slightly differently, through memory, culture, imagination. For some, it's a map for navigation. For others, a source of wonder or prayer. The edge of perspective isn't just physical, it's personal. It's the point where comprehension meets mystery. Beyond it lies not nothingness, but everything we have yet to understand. Sometimes, when you look up at the stars, it's hard to feel connected to such vast scales. The numbers lose their shape. Distances stop meaning anything. But the edge of perspective isn't meant to make you feel small. It's meant to remind you that being part of something infinite doesn't diminish you. It gives your existence context. The light that reaches you has travelled across time, and now it ends its journey in your awareness. In that moment, you become part of the process, the receiver of light, the consciousness that completes its path. The universe extends through you, not just around you. When the first deep space images came back from telescopes orbiting Earth, astronomers noticed something quietly astonishing. The further they looked, the more galaxies they found. But those galaxies weren't random. They formed patterns, filaments, clusters, and voids, suggesting that the universe has structure on every scale. It's as though matter, given enough time, arranges itself in harmony, responding to gravity's slow pull like notes finding their place in a chord. Even chaos has rhythm, even emptiness has form. The edge of perspective isn't a cliff, it's a horizon that reveals more the closer you get to it. And beyond that horizon, there are questions we can't yet answer. Does the universe have an edge, or does it curve back on itself like the surface of a sphere? Is there more beyond what we can see, perhaps other universes, each with its own laws and light? These questions may never be fully resolved, but they remind us that understanding is always temporary. Each discovery replaces one mystery with another. That's not a failure of knowledge, it's the essence of it. Curiosity thrives at the edge of perspective. It's what keeps us looking outward and inward, both at once. If you think about it, perspective has always defined humanity's relationship with the cosmos. Early people looked up and saw gods and stories. Later we saw patterns, constellations, guides for navigation and calendars. Then we saw worlds, planets like ours, moons, and distant suns. Each shift expanded our sense of scale, and at the same time, our sense of humility. The edge keeps moving, and with it, our understanding of ourselves. There's a kind of grace in that expansion. The further we see, the more we realize how connected everything is. The atoms in your body once drifted through the interstellar medium, and the light reaching your eyes tonight may have left its source before Earth existed. The universe isn't out there somewhere. It's the medium we inhabit, the substance from which we're built. To recognize that is to see the edge of perspective not as a boundary, but as an invitation. You can feel it in quiet moments, when you stand beneath the stars or see a photograph from a distant spacecraft, or read about galaxies billions of light years away. It's the sensation of comprehension brushing against the infinite. The mind reaches outward, meets the limit, and instead of frustration feels awe. That's the natural response to the edge of perspective. Wonder without conclusion. And even though the universe stretches far beyond what we can see, we can trace its origin back to a single moment. The Big Bang, the expansion of space itself. Everything we know, every atom and photon, every law and constant emerge from that beginning. Space and time unfolded together, carrying matter outward, forming stars, galaxies, and eventually the consciousness now reflecting on it. The edge of perspective, then, isn't just spatial. It's temporal. It's the edge of time, the boundary between the known past and the unknowable before. When you gaze at the night sky, you're looking across that history. The nearest stars show you the recent past, a few years, a few decades ago. The most distant galaxies show you the young universe, when it was just beginning to take shape. Between those two extremes lies everything, the full arc of cosmic evolution written in light. The universe doesn't hide its story, it displays it openly across the sky, if you know how to read it. The deeper our understanding grows, the more personal it becomes. Knowing that your body is made of atoms forged in stars doesn't make you abstract. It makes you intimate with the cosmos. Knowing that the light you see has travelled billions of years doesn't make you detached. It makes you part of that journey. The edge of perspective isn't out there. It's within you, expanding every time you look, think, or dream beyond what you already know. And maybe that's what it means to live in a universe so large, to accept that there will always be horizons, always limits, always mysteries beyond reach. But within those limits there's meaning, there's light and thought, and the quiet satisfaction of knowing that even at the edge of perception, we're still connected to everything beyond it. The boundary doesn't separate us from the universe, it defines our way of seeing it. Someday our descendants may see farther. They may build instruments capable of observing light older and fainter than anything we can detect now. They may peer beyond our current horizon and find new structures, new patterns, perhaps even new forms of existence. But even then there will be another edge, another horizon, another point where understanding fades into mystery. And when that happens, they will stand where we stand now, at the boundary of sight, looking into the unknown, filled not with fear, but with wonder. Because that's the essence of perspective. It's not about how much you can see, but about how deeply you can feel the distance between knowing and not knowing. To live at the edge of perspective is to be constantly reminded that discovery and humility are the same thing. Every answer opens another question, and every view of the universe, no matter how wide, ends with the same feeling, awe. So when you look up tonight and see the faint line of the Milky Way, or a single bright star cutting through the dark, remember that you're standing on a planet orbiting one sun among billions, in a galaxy among billions more, each shining, each receding, each sending light across the universe toward you. The edge of perspective isn't the end of vision. It's the beginning of understanding that vision itself is infinite. If you sit outside long enough, beneath the dim wash of starlight or under the gentle weight of the sun, you begin to feel something that doesn't belong to any single thought. It's not an idea, not a conclusion, but a quiet awareness, the recognition of simply being here. The mind might wander across everything you've learned, all the distances and scales, all the dazzling numbers that describe the universe. But sooner or later, the complexity softens, and what remains is simple. You are here. The sun still rises, the earth still turns. Light, which has travelled across time and space, still finds you. It's strange how ordinary that can feel, given what it truly means. Every ray of sunlight touching your skin began its journey in the core of the sun millions of years ago. It wandered through plasma, scattered and absorbed, lost and found again, before escaping into space and crossing 93 million miles to reach this small world. The warmth you feel in the morning is ancient. The light falling across leaves, windows and oceans began long before anyone existed to notice it. And yet, here it is, finishing its long journey, not in silence, but in perception, in your eyes, in your senses, in your life. That light is a reminder that time and existence aren't separate things. They flow together, like air and breath. The light that left the sun long ago is only now becoming part of your present. The energy that once existed as nuclear fire inside a star now moves through the air as heat, through your body as warmth, through your thoughts as awareness. The universe doesn't send its light into emptiness, it sends it into continuity. You're part of that chain, one link among countless others. If you look around during the day, everything you see exists because of light. It isn't only what illuminates the world, it's what gives the world its meaning. Plants reach for it, water reflects it, air scatters it into colour. Every movement of wind and tide, every living thing, depends on it. Even when the sun slips below the horizon, its influence remains, stored in the warmth of the ground, reflected from the moon, refracted in twilight's fading glow. The light never really leaves. It just changes form, softening as day becomes night. And when night comes, that same sun, now hidden from view, is still shining. Not for you, but for other parts of the world, for oceans and continents that turn into its face as you turn away. The continuity never stops. Somewhere, always, it is day. Somewhere, always, light is falling across faces, fields and seas. The planet spins in its rhythm, one half illuminated, one half at rest, both halves sharing the same motion. The stillness we feel at night is not stillness at all. It's the balance point in an ongoing rotation, the calm within motion. That rhythm has always been here. Long before humans existed, the Earth was turning beneath the same sun, its light warming ancient seas, feeding the chemistry that would one day become life. That cycle, sunrise and sunset, day and night, has repeated billions of times. It's easy to think of it as ordinary because it happens every day, but that repetition is the foundation of everything. The sun has kept that rhythm without pause for nearly 5 billion years. It will keep it for billions more until its quiet engine within finally runs low and the pattern changes. For now, though, the pattern holds, and we live within it. It's comforting to know that something so vast and impersonal can also feel intimate. The sun doesn't know you, but it knows where you are in the only way that matters. It reaches you with its light. It falls equally on all things. Mountains, oceans, cities, the smallest blade of grass. It draws no boundary between living and non-living, between human and stone. It just shines. To exist beneath that light is to belong to the same physical law, the same quiet generosity that powers the stars. Every morning the sunlight that floods the world feels new, but it's part of an unbroken chain that began at the dawn of time. The first stars that formed in the universe burned with light that scattered elements across space, creating the raw materials for later stars, including our sun. That same process continues even now across billions of galaxies. The light you see each day is part of that ancient continuum, the universe remembering itself, one photon at a time. It's remarkable to think that the human body itself is, in a sense, an extension of that light. The energy that keeps you alive, the food you eat, the air you breathe, originates from the sun's radiation. Plants capture it through photosynthesis, converting it into the chemistry that sustains everything else. Every heartbeat, every movement, every thought is powered by sunlight transformed. To say that you live beneath the light is true, but it's also incomplete. You live because of it. You are sunlight, slowed down and shaped into consciousness. And yet, for all its power, light is fragile. A single shadow can block it, a cloud can soften it, a turn of the earth can hide it completely. The contrast between light and darkness defines every moment of perception. Without night, we wouldn't understand day. Without darkness, we wouldn't see stars. The alternation between the two creates rhythm, giving the world texture and time. Even rest, even sleep, exists because the planet turns away from light for a while. The cycle of illumination and shadow is not just physical. It's woven into how life functions, how thought and emotion rise and fall. When you close your eyes at night, the sun is still shining somewhere, but in that darkness, something else becomes visible. The stars, distant and steady, emerge to remind you of the larger world you're part of. You're no longer just beneath the sun's light, you're beneath the light of the galaxy itself. Starlight from countless suns, each one contributing to the faint glow that fills the sky. Those stars are so far away that their light began before your species existed. You're seeing not just across space, but through history. The Milky Way's soft band, stretching from horizon to horizon, is the visible reminder of that history. It's the collective light of billions of stars all shining together, their photons crossing unimaginable distances to reach your eyes. It's easy to forget while standing in that glow that every one of those stars is a sun. Each could have its own planets, its own skies, perhaps even its own beings looking back. The light above you and the light that warms you come from the same kind of source. Distant or near, they're all part of the same continuum. When you think about it, the story of light is the story of everything. The universe began in darkness, but almost immediately it became light, energy expanding, cooling, forming atoms, stars, and galaxies. Every photon released since then has travelled outward, carrying information about where it came from. That's what makes light such a profound thing. It remembers. It records distance, motion, temperature, and time. When we look into space, we're reading those memories. The entire cosmos is a collection of light in motion unfolding forever, and through all of that you remain here, beneath it, part of it. The Earth turns, seasons change, light fades and returns, and still life continues. The continuity of it all can feel almost too large to hold in your mind. You could live an entire lifetime and never see the sun change, never notice the slow drift of stars, and yet everything around you is in motion, quiet, patient, unstoppable. That patience is what defines the universe. It doesn't rush. It moves according to its own rhythm, one that includes you without needing to acknowledge you. There's comfort in that steadiness. The same light that warms you today will shine on others long after you're gone. The same sun that rises for you rises for generations past and future. Its constancy weaves your brief life into a pattern much larger than you. That's not a loss of importance, it's an expansion of belonging. You're temporary, yes, but you exist within something that endures. The light doesn't need to last forever for it to mean something, it just needs to reach you once. Sometimes, when the morning sun spills through the window, or when the last rays of evening turn the sky amber and rose, there's a moment when time seems to pause. You can feel the warmth on your face, see the light move across surfaces, and realize that everything in that moment, the light, the air, the breath, is part of the same physics that governs galaxies. The simple act of existing beneath light connects you to everything from the smallest atom to the largest cluster of stars. It's all the same story, continuing without interruption. Even the shadows we create, the patterns of darkness cast by our own presence, are part of that story. Light defines them, shapes them, gives them movement. Without light there would be no shadow, and without shadow no form. It's a quiet reminder that everything we experience, even the contrast, depends on illumination. You can't separate yourself from it. You're both the one standing in the light and the one casting the shadow. In the end, being here beneath the light means recognizing that you are part of the same continuity that began long before you and will continue long after. The sun, the earth, the galaxy, the universe, all of it moves according to the same laws, and all of it shares the same fate of transformation. Stars burn out, planets erode, galaxies drift apart. But the light continues. Energy changes form, never destroyed, always becoming something else. When you breathe, when you think, when you rest, you're participating in that transformation, a small, local expression of a universal rhythm. It's easy to let that thought drift toward melancholy, but it doesn't have to. There's peace in knowing that nothing is wasted. The atoms in your body will someday return to the earth, to air and water, to new forms of life. The light that sustains you now will move on to others. The cycle doesn't end, it evolves. The universe doesn't hold still, it keeps creating. You're not outside that creation, you're its continuation. And maybe that's what it means to be alive in a cosmic sense. Not to control or to conquer, but to participate, to notice. To feel sunlight on your skin and starlight in your thoughts, to be aware of the vastness and still feel peace within it, to understand that even at the smallest scale, you're part of something perfect in its incompleteness. So here you are, still here, beneath the light. The sun rises, and with it, the world stirs again. The air warms, the shadows shrink, and another day begins. Everything that has ever lived, everything that ever will, shares this same moment of illumination in one way or another. The light that fills the world isn't just a physical thing, It's the quiet connection that ties all existence together. And as the day unfolds and time moves gently forward, the light continues to do what it has always done, to fall, to reflect, to fade, to return. You don't have to chase it. You only have to be here when it arrives. The rest, as it always has, will take care of itself. Because no matter how vast the universe is, no matter how far perspective stretches or how long time runs, there will always be this. The feeling of being alive, still here, still aware, still beneath the light.